Hi, good morning, everyone. How is everybody doing today? So, Anurag is saying, I didn't see yesterday's presentation uploaded to LWM. Oh, is it? I thought it was uploaded. Let me quickly check. Okay, so I'll take back. So, Anurag, I'll talk to our um, admin team and see why the presentation is not yet uploaded because it was supposed to be uploaded in 6 months. Sorry, in 6 hours. So, good morning, Suman. So, Narsimha, yeah. So, yeah, Anurag also says the same thing that he did not see the session from yesterday. So, I will talk to our admin team and see why presentation was not uploaded. Madhu also has same question that presentation has not been uploaded, but Gandhi says that it is uploaded. So he says he has seen it. So looks like maybe you guys need to log in again. Maybe you checked like before 6 hours. So that's why it might not have been there. So if you log in once more, I think you should have some. I had the latest video. Good evening, Raghu and Ravindra. Good morning, and good morning to Rudra. So Anurag, yeah. So if you could try checking it once more. So I see that Anurag is saying that he was not able to attend last 30 minutes of the session. So that's why he wanted to see the presentation on the learning management system. But Anurag, can you try logging in once more and see because some people were able to see the latest presentation from yesterday. So maybe you opened it like before they uploaded it. So it would be good if you could try it once more. Good morning, Vikrant. And good evening, Niladri. So Gandhi is saying that it is under module one, overview of Hadoop cluster administration. Yeah, that's where I think it should be because yesterday we covered module one. So Anurag is saying there are the old presentations on LWM. So Anurag, if you check once more, you can see the recording. Gandhi is saying the name is class one recording. So just try to look for that recording. And Ravindra is saying that refreshing the web page shows the session. So maybe you need to refresh the web page. Thanks, Gandhi and Ravindra, for letting us know that you were able to see the session. So that's great. Okay, so looks like we have everyone and we can get started, I guess. Maybe we are missing one person, I guess. Is everybody able to hear me fine? Okay, so Raghunath is saying the instructions for setting the VM and lab seems a little hard to follow, and he was trying to set up a single CentOS node. So that's something that we are going to try. So Niladri is saying that my voice is sometimes too low. So let me see how I can fix that. Is it better now, Niladri? Okay, so hopefully, yeah, now I think the voice should not be bad. So sorry about that. Okay, so yeah, in case anybody finds the volume not audible and my voice is not audible, so please point me out right away so that I can look at my headphone and see if there's something wrong. But I think it should be fine from now. So Ravindra is saying, do we need internet connection to follow the steps to install single node? So Ravindra, there are some things that you have to download. That for that you might need internet. For example, you have to download the Hadoop version, Hadoop binaries. Then you have to download Java version. So for that you do need internet connection. So actually, we are going to today do installation. So I guess that should help you with some of the difficulties that you faced yesterday in trying to set up the node. So we are going to try that today, and then I guess you can try it again once more after the session. Okay, so looks like we should be able to get started now. So if somebody still doesn't see the presentation from yesterday's session, so please send an email to our support team so they can send you the exact instructions. So basically you can just email at hadoop@edureka.in. So they should be able to send you or point you to the presentation from yesterday's session. Anurag, especially for you since you were not able to see it. Okay, so looks like we should get started. So, um, so as we saw this course yesterday, that we module one was understanding big data. What is a typical Hadoop cluster? What does it look like? And then what are the main Hadoop cluster administrator roles and responsibilities? And then we looked at an introduction about Hadoop 1.0. What are the main components in Hadoop 1.0? So today's agenda is basically to look at Hadoop, do a bit revision of what we did yesterday, and then go to Hadoop 2.0. And we are going to actually try install a single node cluster and then look at what are the main Hadoop cluster configuration files that we need to basically alter, and then basically look at the cluster architecture. So these are things that we are going to do today. So any questions about today or any concerns? So Nanda Kumar has a question that Hadoop fs-put local source to destination and Hadoop fs-copy from local source to destination. So that's what's the difference. So basically there's no difference. So put also puts data from local file system to HDFS, and copy from local also does the same thing. So basically essentially they are same. So there is put and get, and then there is copy from local, and there is copy to local. So basically we will see these as we go along the course. So can you, so Niladri has a question. Can you please explain briefly what is CDH3 and what is CDH4? Yeah, sure. So CDH, as we discussed yesterday, is Cloudera distribution for Hadoop. And Cloudera has like a major release every year, which is like CDH3, which was CDH3 in 2012, CDH4 in 2013, and in 2014, they have CDH5. So basically, these are the major releases that Cloudera does. So it does one big release every year, and then all the patches that keep on coming every year by Apache or Hortonworks or Cloudera or anybody who contributes the patches to Apache Hadoop, they become like the minor subversion. So like with CDH4, we had CDH 4.0.1, then Cloudera released CDH 4.2.1, then they released 4.3, and the latest one is 4.5. So that was released last year, and now they are on CDH5. And initially they had CDH5 beta, which was the initial version, and now they have going to have CDH5 GA release, which will be installed by most enterprises in production. So that's basically the release versioning of Cloudera that they uses. So CDH3 or 4 means one major release, and all the minor releases they keep on coming all around the year. So hope that explains the difference between 3 and 4. And 3 and 4 major differences, like same thing, like as Apache Hadoop community keeps on fixing things, so all the new features they keep on coming. So CDH3 was in 2012 and CDH4 came in 2013, to where they had a lot of new features, which was basically Hive Server 2, HBase, and they added name node HA, job tracker HA, job tracker restart feature, that if job tracker say is restarted in between, so it should not fail the jobs. So they're like keep all the new features, they keep on coming in later and later releases. So CDS 3 is now like obsolete. So with that means people are not going to install it in production. So CDS 4 is still installed everywhere, and it is going to be supported by Cloudera for at least 2 years more. So that's a major difference. Okay, so Nanda Kumar. So it's different than Apache Hadoop is Niladri's question. Yes. So basically, it is the Cloudera distribution for Hadoop. So basically, Apache is an open source community, so they have Hadoop distribution, but Cloudera basically creates this version of CDH on top of those Apache fixes, and they create their own release cycle where they include Apache fixes as well as they include their own fixes also. So CDH 4.5 is Hadoop 2. Yes, Rudigar, it is CDH 4.5 is Hadoop 2, and it also supports Hadoop 1 because a lot of people are still on Hadoop 1 and they're going to stay on Hadoop 1 for a long time. So it's struggling for bandwidth. So can everybody hear my voice? Looks like Raghunath has some trouble hearing me. Let me know if everybody has problem hearing me. So Suman says that there is no issue and everybody else is able to hear. Okay, so looks like everybody is able to hear. So Raghunath, I am not sure why there is some problem happening at your end. So do you want to check if something is wrong with the with your headphone or something? Okay, so yeah, so looks like everybody else is able to hear, so we should just get started. So here are the topics for today. What we are going to do is we are going to do a revision of what we did yesterday, since it's a new thing and it was like first class, and a lot of people would now, after they read it, they might be able to do a quick recap. So we are going to do a quick revision, and then we are going to look at Hadoop 2.0, and then we are going to look at Hadoop 2.0 configuration files, and then we are going to look at the cluster modes. What are in what different kinds of mode you can run a cluster, and what is the cluster architecture look like in terms of racks and everything, and how to plan your Hadoop cluster, what kind of hardware you should look at, and when you plan your Hadoop cluster, what kind of software you should look at. So those are the main things that we cover, and then we are also going to look at popular Hadoop distributions. So it's like Niladri asked about CDH3. So we are going to look at some of the popular uh, uh, new Hadoop distributions. So someone is saying a lot of new things to digest. Yes, that's true. So that's why we have like two classes, then a gap between, so that you get time to read, you want get time to do your homework on those two classes and able to basically digest all the things that we all the new things that come up every day. So yeah, so hopefully I guess after this class you will get a break of about 5 6 days, so you should be able to like read this and come next week more refreshed with new questions. So okay, so let's do a quick revision of what we did yesterday. What are the Hadoop core components and Hadoop 2.0 basics? So if we look here, this is the same slide that we saw yesterday. So we have two main components. There is HDFS and there is MapReduce. And whenever you run something, you run from a client machine. So basically you always go to a client first and you type commands from there. So you can either query data through HDFS where you want to read the data or you want to write the data, or you can run a job through MapReduce. So in HDFS framework, we have name node, which is the main metastore metadata of the system. So all the data nodes, they basically are slaves of name node, and name node basically decides where to send the new data and the data nodes are basically going to host all the data in the cluster. And then we have secondary name node, which is basically not a hot standby node. It is just a checkpointing node, which is basically going to every hour or based on the configuration value, it's going to basically poll name node and store metadata every hour, or based on your configuration every few hours or every few minutes, so however you want to do it. And all the data nodes, they are basically going to store the data blocks. So every data that comes is divided into set of blocks, and block size is by default 64 MB, and but most organizations they bump it up to 128 MB. And then under MapReduce, we have Job Tracker, which is the master node. It takes care of handling the jobs. So, and it has a set of task trackers, which are basically slaves for Job Tracker, and they typically run on the same machines where data node run. And task trackers run tasks, and those tasks can be either map task or a reduce task. So basically a mapper or a reducer. So this is a brief recap of Hadoop 1.x. So any questions, anybody? If somebody went home and read and they are still confused with something in Hadoop 1.x? Okay, if not, then we will basically go to the next slide, which is the differences that we saw about Hadoop 1.x versus Hadoop 2.x. So we saw that name node in 1.x is 1, but in 2.x you can have a lot of name nodes, and high availability is not present in Hadoop 1, but in Hadoop 2 it is highly available. There are a lot of different components that are adding to high availability. There's name node high availability, there is job tracker high availability, and you can have zookeeper nodes, which will also cover once we move ahead. So in the course. And then we have processing control. Job tracker was like a bottleneck in Hadoop 1.x. So in Hadoop 2.x, we have a resource manager, we have node manager, and we have application masters. So basically, they help to run just not mappers or reducer kind of tasks. They let you run any kind of application on Hadoop. So it basically helps with integration of all the different kind of systems, not just map reduce kind of frameworks. Okay, so let's take a quick look at the Hadoop.x 2.x HDFS federation. So here again we have name node, which stays the same. The storage layer is again data node, so that stays the same, which is HDFS, Hadoop Distributed File System. So the data node layer is still the same, and data nodes still do the same thing. They will get the data from outside. It comes to name node. Name node decides which data node should have the data. So data node store the data, and when they come up, they tell their state to name node that I have these many blocks. So based on that, name node has a block report of every data node, and it basically knows what data node has what data, and those are the kind of things that basically comprise the metadata of the complete Hadoop cluster. And so name node basically has the complete mapping of this, and that's how the HDFS system works. So which is still the same in Hadoop 2.x. But the major difference that we see is under the MapReduce layer. So if you see here, data nodes are basically going to form the same storage layer, but at the top we can have multiple name nodes. And then when we talk about name node, we say namespace. So basically all the nodes in the cluster are basically contributing to the capacity of the cluster. So data node has, say, one data node has say 100 blocks, second data node has another 100 blocks. So they are basically all together, they are having say 200 nodes. So those 200 blocks are basically the blocks of the system of the HDFS cluster, and they form the namespace. So in 1.x we had just one name node and one namespace, but in 2.x we can have multiple name nodes. So they basically have their own namespaces, but the block pool is shared. So basically they still know that the complete cluster has these many blocks, and they still get the same image of the blocks, but their namespace is different. So if one of them goes down, the other name node can still basically take it up from there, and it can still serve the system. So that's how we achieve the high availability and federation system. So that's the main function, a main feature in Hadoop 2.x, which is called federation. So basically, you if you go down, you are basically working as a federation, and some other guy would come and pick it up from there, and the system would still be available. And this is achieved with the help of Zookeeper, which we will see as we go along the course. It will be covered in the future slides, that sorry, in the future modules, not in today's slide. In the future sessions, we are going to cover a bit about Zookeepers, how basically they share the things, and how name they pick up the next name node if one name node goes down. So basically now name node is not a single point of failure, so now we have multiple name nodes. So Niladi has a question. Can you please explain what is namespace again, please? Yeah. So namespace basically we are saying is the complete metadata of a cluster is basically uh, known by a name node. So that complete state of the system comprises the namespace. So all the data nodes combinedly are storing all the data of the cluster. And name node knows about which data node has what number of blocks and which data node is hosting what kind of blocks. So that complete image of the cluster is known to the name node, and the name node basically we say is that is basically the namespace. So this name node is basically forming a namespace, and it has the knowledge of all the data nodes in the cluster. So that is basically the namespace in a HDFS cluster. So in federation, basically we are saying that every name node will have a different namespace because it is maintaining that individual state on its own machine. It is not shared across the cluster. So every name node still maintains its own state in terms of where it stores the metadata. So that's why the name node will have a namespace. Every name node will have its own namespace in Federation also. So do you have any PDF? Are you going to give us some documents? So that's a question by Vinod, that do you have any PDFs? So Vinod, again, what this presentation that we discussed and the uh, exercises, everything is under learning management system. So let me show once more. So we briefly looked at this yesterday, right? So this was the yesterday's module that we looked at. So today we are doing this module. So if you see, there is going to be a recording there. There's going to be the presentation that I'm that so that's the PDF. Then there going to be is going to be a quiz. There's an assignment that you have to do, and then it also prepares you for the next session, next day, next week's basically module that like pig and hive setup we are not doing today, but this is given as an assignment so that for the next class you come prepared a little bit where what is pig and what is hive. So what, because if we give this to you, you will read about it and you will be more prepared and you might ask more relevant questions. So this is just to make sure that course is steered in the right direction. So virtual multi-node Hadoop cluster, setting up multi-node Hadoop cluster on AWS. So all these are like part of the documentation that we have. So Vikrant has a question. 2.x HDFS Federation multiple name nodes are redundant to each other. So they are redundant to each other. I would not say they are redundant to each other. They are redundant in the system because we want high availability. So whenever you have a high available system, you want redundancy, that if one primary node goes down, secondary name node should come up. So they are redundant in the system. They're not redundant to each other. They have their own namespace that they are maintaining. If one of them goes down, basically the other one takes up. Plus we are also going to discuss all this in our future modules a lot more. So Vikrant, that would also help you with further understanding this. Yeah, so Niladri is also answering to Vinod's question that PDFs are there in LMS. So Vinod, you should be able to see them. If you don't see them, again, you can always send an email to hadoopadmin@edureka.in or call at the number, and they should be able to point you to the right place. So Vinod is saying that he is not asking about the presentation, but other documents. Yeah, so we just basically looked at other documents. So in case you still have questions, you can always email support. So Rudra has a question. In case of federation, in order to get HA, do we need to have standby node for every primary node like name node should have? NS11 as standby. No, basically all these name nodes that you see, NN1, NNK, NNN. So basically, suppose we say these are three name nodes. So these three name nodes are actually acting as primary as well as standby. So if one of them goes down, the other one picks up. So basically these are basically we are talking saying that these are the federated name nodes. So they are all there, and if one of them goes up, so Zookeeper will basically see which of them is up at a good state and will just pick that name node and make it primary. So we'll also see in future things that in when we talk about name node high availability, there is an automatic failover, and then there is a um, manual failover. So when you have a manual failover, then the name node doesn't pick up. But when you configure automatic failover, then name node just picks up from that point, and the cluster doesn't go down. So in case of manual failover, the cluster will go down because name node goes down. You have to manually start the name node on the others node and then bring it up. But when you configure automatic failover, that's done using Zookeepers. So in that case, the name nodes, if one name node goes down, the other one will automatically become the primary name node and the cluster won't be down. So Niladri also has a suggestion for Vinod that he can look into 2.0 old class session, so he will see some other documents there also. Thanks, Niladri. Okay, so let's look at a little bit about name node high availability. It looks like Rudra also had a question, so hopefully this would help him understanding. So again, the same thing, the data node layer is still the same. And when we say name node, we are going to have one name node and there's one standby name node, and they are basically going to have a shared edit logs directory where they are both of them are going to write. But but the thing is that all name space edits are written to this NFS directory, and there will be only a single writer, which is going to be the active name node. So standby name node will just periodically sync the edit logs and apply it to its own namespace. So basically, standby name node is not going to write anything. It is just keep on reading edit logs and keep its state updated for that event. When active name node goes down, it has to become primary. So that's the difference here, that only one name node is going to write the edit log. So basically, I don't um, know if everybody remembers what edit logs are. So edit logs are basically the all the changes that happen in the system. For example, name node has a state of the system, and then somebody came in and he read a file. Somebody wrote a file. So the change system states changes, and then name node will have an entry of the new state in the edit logs. So basically, name node will be updating edit logs all the time. So that's why standby name node needs to make sure that it gets that edit logs from the shared NFS or just from the local disk drive of the active name node. So that those are the two kind of configurations with the name node HA. You can even do you can do either an NFS based um, HA, or you can do a quorum based HA, where you just have Zookeepers and all the name nodes. They don't write to any NFS, they write to their local file systems. And the second name node is going to basically SSH to first name node and read it from there. So all these things I think we'll also going to cover in our future sessions. So this is just to make sure that we know exactly what's going on with 2.x and what are the differences. So Narsima says, can you please explain the term single writer fencing? So Narsima, I just explained. So is it any clear now? So single writer means that only one active name node would be writing to the edit logs at a time. Both the name nodes are not going to write, because then there would be a race condition and some writes from one name node will fail. The second name node will try to write, they won't be able to access it. So that's why they have kept it simple. They say that only the active name node is going to be the writer, and that's how it is basically fencing the edit logs. And standby name node is just going to read it and then apply it to own namespace and make its own namespace current. So Madhus has a question. uh, When active node is down, then does standby connect to secondary name node? So secondary name node is totally different here. So secondary name node is still doing the same thing, basically doing the checkpointing. So basically it is still just going to the active name node and trying to get the metadata and try to just keep a copy with it every hour. So standby secondary name node is going to be always doing its own thing. It's not involved with active and standby name node. So because active name node and standby name node are acting as primary and secondary, this secondary name node in the box that says secondary name node is still the checkpointing node basically, which is just going to connect to the active name node, whichever is the active name node, and get the metadata and just keep it in its own machine. So in case of the event that both the name nodes go down, then what happens? In that case, secondary name node would have the metadata, and then when the name node comes up, then we can use the metadata from secondary name node and bring the system up. So Akash has a question. Can you please show a sample edit log? Yes, Akash. So once we do the installation and as we progress, we are going to look at all these things. So Ravinder is saying, what happens when there is any damage to edit logs? From where can we recover them? Yes. So it's the same thing, Ravinder, that when we configure name node, we always configure it to write to few different disk drives. So if you say write to a partition on disk say nn1, then you will also create another directory nn2, so which will be a different partition. So in case your one disk volume goes bad, it will still have that other disk volume. And other than that, we also try to write it to an NFS location. So basically, we try when we configure where name node should write metadata, we can configure like any number of places where name node should update it at the same time. So whenever name node does any update, it would update it everywhere. So in case there is damage to say one disk volume which has edit logs, the other one would still have the latest copy and name node would still be up. Plus you will always, if you configure NFS, then you'll also have it on the network. So in that case you don't have to recover, but if all the copies go bad, then you need to recover. So in that case you can go to secondary name node, because that's the whole purpose of having this secondary checkpointing name node, that in case name node goes down and we don't have any copy of the latest state, so we will at least get the last say state that secondary name node copy, because secondary name node is copying every hour. Say it is copying at say every hour boundary, and the name node went down at say 30th minute of that hour. So for those 30 minutes we won't have the state of the system, but before prior to that 30 minutes we can still get everything from this secondary checkpointing node, which is better than having nothing. So that's why we have this checkpointing node. So hope that answers your question, Ravindra. So Vinod Kumar is asking, John, are you teaching from India or US? So I'm teaching from US. Yes, so that's why you see my time zone as 7 p.m. Okay. Right. So is the metadata different from the shared edit logs? So Raghunath has a question. Is metadata different from the shared edit logs? So when we talk about metadata, so basically there are two main files which we will see once we install the cluster. There is an fs image and then there is an edit logs. So fs image will basically have all the state, and edit logs will be the changes that happened in last few minutes. And after some time, NameNode basically combines fs image and adds edit logs to fs image, so that you get the new file system image. So basically we have two main files which store the metadata. It is fs image and then it is edit logs. So fs image is file system image, where NameNode will have the mapping of the blocks per data node and all the operations that happen. And then we have edit logs, where we'll have the latest changes that happen, that some block got deleted, somebody say ran a job and it creates some more new output, so new data came to data nodes. So those kind of changes would be in the edit logs, and periodically name node merges this and creates the new fs image. Okay, so hope that answers your question, Ravindra. So Niladri is saying, is writing metadata and log in multiple locations, does this not impact performance? No, it does not impact, because you're just writing. Basically, you should look at that, what are you gaining from it? Because if you just write it to one location and that one day that one drive goes bad, then you have nothing. If somebody is basically uh, I'm sorry. Sorry about that. So basically, what we're discussing is that if, say, you just write it at one location and that one location someday just that disk drive gets corrupted, so in that case, you don't have anything and your cluster basically lost everything. So suppose you stored like 2 years worth of data, and then one day this disk drive went bad and you didn't write it to any other location and just one location. So in that case, you are basically going to lose everything. So which is much better than having a slight performance hit. It might be like few seconds, few milliseconds to write to multiple locations, but the gains are huge. So in almost all production system and enterprises, you will see that people definitely write it at multiple locations. Okay, so Raghunath has another question. Can we use the metadata from secondary name node and edit logs to bring the system to point in recovery? Yes. So basically, now we are going to use secondary name node in an event that your primary name node basically goes down, right? So in that case, you won't have any edit logs. So basically, when primary name node, I should not say primary, just the name node goes down, then basically you have lost your FS image and you have lost your logs, edit logs also. So in that case, if you lost both of them, then you don't have edit logs. So only thing that you have is in that case secondary name nodes last hour's backup, which is both FS image as well as edit logs. So you just basically bring both of them and put it in the name node directory and bring it up. So that's how you basically recover in 1.x. Okay, so if there are no more questions on this slide, we can move to our next slide. So 2.x yarn, what exactly does it do? So yarn is basically yet another resource negotiator. So how we see the architecture here is that we have clients, then we have resource manager. So resource manager is basically going to take care of the resources, and then we have node managers. So these node managers are basically kind of a replacement for task tracker. They are going to run on the data nodes, and then they'll have a container and they have an application master. So now application master is basically going to be responsible for each application. So in 1.x we used to have job tracker. Job tracker was responsible for all the jobs in the system. So now the difference is that we have application master, and each application will have an application master, and that application master will be responsible for that job. So basically, instead of having a centralized job tracker, now we have decentralized it, and all applications are going to individually take care of their jobs. So which gives a better performance, because then job tracker was like a single point of congestion or slowness. So that's the main architecture change in terms of yarn that has been done. um, so Raghunath still has a question about the metadata that we discussed before this slide. So he was saying that, but the edit logs were written to different locations. Yes. So Raghunath, yeah, that's what. So if the name nodes drive goes down, then definitely if you have NFS location where you wrote both FS image and edit logs, you can bring it from there. Yes. That's why we basically write to multiple locations on the name node. Then we try to write it on a network filer also. And then on top of that, we have every hour think backup done by secondary name node. Okay, Gandhi has another question. When data nodes are updating blocks and heartbeats to both the name nodes, what is the advantage of disadvantage of having edit logs? So basically, these are two kind of two different things. So edit logs is basically maintained by name nodes. So data nodes are always going to basically, data nodes are like slaves. They are going to basically serve the needs of the name node. They are going to write data, they are going to write the blocks, or they are going to basically read the blocks, and they are going to send the status back to name node. And name node is basically going to interact with the client. So from the client side, the request will come that I want to write a file. So name node is basically going to see that, okay, I'm going to split this file into blocks, and I will send first block to 10th data node, second block to fifth data node. So all those blocks are basically handled by data nodes, and name node is going to have this kind of edit logging that I changed this block on this data node, I changed this block on this data node. So those kind of logging is done by name node. So Vikrant has another question. Whatever it writes in edit logs does it load in memory immediately? So basically, FS image and edit logs are always in memory, because that's why name node has to have is to be a machine, a beefy machine where you have a lot of RAM, because name node keeps metadata in memory. Because that's how it can be quick and respond to all the requests. Because if it's not in memory, then it has to fetch the block, it has to do some kind of indexing, the fetch the block from this, and the name node response time would be very slow. So name node always keeps the metadata, which is FS image, in memory. Um, so that's why name node has a huge memory requirement. So hope that answers your question, Vikrant. So Narasimha is saying, is it possible to use data from secondary name node and edit logs from one node to replicate the data in another node? Okay, so let's read this question once more. Is it possible to use data from secondary name node and edit logs from one node to replicate the data in another node? So secondary name node doesn't have any data, it just has the metadata, right? So it will have FS image and edit logs from a particular snapshot of time. And so if you have to replicate from one node to another, that replication would be done by name node. So name node is going to basically do any things that needs to be happen on data node. If some data needs to be deleted, name node is going to tell which data nodes to delete which blocks. If some data needs to be written, name node is going to tell which data node to write which blocks. So those kind of tasks are all handled by name node. Secondary name node is only going to save the metadata, which is FS image and the edit logs. So Akash has a question with the present slide, that can there be a node manager without application master? So again, these are different, basically these two are serving different purposes. The node manager is responsible for that particular node. Like in 1.x, we have task tracker, which is responsible for spawning a task and sending the status back to job tracker. So node manager is doing that thing in this case, which is basically communicating with resource manager and sending the status back to resource manager, whereas application master could be on any of the node manager and basically taking care of the application. So can there be a node manager without application master? No, basically you will have application master on all the nodes, which is taking care of that application. So Vikrant is saying, so edit logs is part of metadata. Yes. So both FS image combined with edit logs gives you the current state of the system. If you look at FS image, it might be few minutes from now, few minutes ago from now. It won't be the latest state. So because FS image is updated by name nodes, basically edit logs are combined to FS image by name node every few minutes. So edit logs has some changes, but FS image is like the final state, but it does not have the last few changes happened on the system. So basically, yes, edit logs are part of metadata. Okay, thanks, Nasima. So you got your answer. So Niladri has a question that what is container? So container is basically, if we see here, so basically containers are basically talking to application master. So application master will basically start, which take care of the application, and on node manager, those instances would run. So those instances are like containers which are running on the node manager, and application master is on one of the node managers, and it is talking to all the containers and getting the status back. Like previously we had job tracker, which was talking to all the task trackers, but now instead of job tracker we have application master, which will run on a node manager, and it will talk to all the other distributed instances going on, which are containers, and they are basically giving status back to application master. So hope that answers your question, Ladri. But then again, we are also going to look this into detail in our future sessions. So this is just to make sure that we understand and basically have a preview of this before we start working on our Hadoop cluster today. So okay. So Vikrant has another question. If edit log is merged into FS image every hour, then whatever update happened in data is not accessible for an hour. Is this correct? So yeah. So Vikrant, edit logs is not merged into FS image every hour. So every hour thing is done by secondary name node to basically get FS image and edit logs to its own system to back it up, to basically do a checkpoint. FS image and edit logs are basically not merged every hour. So name node does it like every few minutes. Okay, so let's move to our next slide. Yep, sorry. Um, yes, basically here also we are having again a look at basically same thing that we discussed previously, that we have shared edit logs, we have single writer and active name node, standby name node, they have data nodes, and on top of data nodes, instead of task trackers, we have node managers, and every application will have an application master that runs on one of the node managers, and on other nodes it will run basically have the container which will basically be giving their status back to application master, and application master will basically go back to resource manager, and then it goes back to the client. So is the function of Rudra has a question, is function of node manager is to monitor containers within a node. So basically node manager is like just maintaining, basically is managing this particular node. So it will see that application master is running, container is running, so it is just providing a way for application master and container to achieve their goal of running the job. So Niladri has a question, a good question. What are clients? So basically, clients are basically so when so you have a cluster, right? So you have name node, you have job tracker. So those are your master nodes, and your data nodes are your slave nodes. So these form your cluster. But when you query, we have to say write a file. You want to query something on the cluster, then you run it from a separate machine, which is called a client or a gateway. So that will basically send a request to name node that I want to read a file, I want to write a file, or it will send a request to job tracker, I want to run a job. So that particular entity is called client, where basically you actually run your programs, where you submit jobs to Hadoop or you query data from Hadoop. So those machines where you do that are clients. So hopefully that answers the question. So Gandhi has a question. What part of 2.0 has replaced the task tracker? Will be the node manager or application master? So node manager and application master are part of the complete Yarn architecture. So if you look on the right side, this top thing, Yarn, which is resource manager, node manager, they are basically, they have replaced, resource manager has kind of replaced job tracker, and node managers are for task trackers. So this is the difference here. Application master would just be like a like a process which is master of that particular job that is submitted. So now it's called application that is submitted, and that application is basically running on node managers, and resource manager and node managers basically just coordinate and send us once job is done, sends node managers which is running an application master would send the status back to resource manager, and then it will send it back to the client. Okay, so let's go to our next slide. Okay, question. So in case somebody has some more questions, we can discuss them, and then we are going to go to setting up a cluster. Okay, so I'm not sure how many of you tried to install a cluster, and I saw, um, I think, who said that it was he was not able to do it. Um, Let me see. Yeah, actually, Raghunath said that he tried to set it up and it was very hard to follow. So that's why we are going to now do like a quick Hadoop installation and then look at the main things that happen in a Hadoop system. So, and Suman also says that she tried to install a single node. So it was giving trouble during startup. Yeah, so all these things we are going to look at now. So let's start with uh, getting our cluster up, and then we can take a look at all the configuration files. So what I am going to do is I'm going to use VirtualBox for this. And for those of you, if somebody has any questions about anything, please write it down and I will basically answer the question. So VirtualBox is basically a tool by Oracle to help you do virtualization. So basically you can run multiple things on your same machine, and that's how we are basically going to install this cluster today. So when you download, you can go to Oracle website and download VirtualBox. So for example, if we go here, go to, so if you see here, so you can go to Oracle VM VirtualBox. So if you go there, you can go to Oracle VirtualBox and you can go to downloads, and you can see that there are downloads for VirtualBox for Windows, for Mac, which is OS X, is for Linux. So it's available for every flavor of OS that you have, so you can basically download it. So that's what I did. I downloaded it for Linux, and then I just opened the download and I got this kind of machine. So what happens is then, so with virtualization, basically you can basically create a virtual machine and have own kind of operating system on it. For example, so if you look at this NN1 that I did, so this is basically a machine where I have 2 gig RAM, and if you go to general, it shows you the kind of system that I have. It is a Linux system, and the version is I'm running Ubuntu, so there's Ubuntu in it. So let's see how we create a new VM image. Before that, Gandhi has a question. If there's a change to a data block on a data node, does the name node first update the information in this memory or write first on edit logs for standby node to sync? Yeah, so again, these are the questions that we are going to cover in our future sessions also. So basically, whenever something changes on the data node, then data node is going to tell name node back as part of its block report that these are changes that happen. So name node basically is going to update the metadata first. And so when you say it's going to update the information in the memory or write first in edit logs, so edit logs are basically part of metadata. So it's going to write it in edit logs, and then it will be both fs image plus edit logs will have that state. So standby node to sync is another thing that Gandhi is asking, that how would standby name node get it. So as we discussed in the slide, that there is a shared edit logs place where name node is writing, the active name node is writing. So in case of 2 dot Hadoop 2, basically, then standby name node will basically go to that edit logs, to that shared location, and get the latest image and edit logs. So standby name node is not going to talk directly to active name node. It is going to that shared location and fetch it from there. So Vinod Kumar has a question: which OS are we going to install? So we are, so like I'm going to work with Ubuntu, but you can try CentOS, you can try Red Hat. So it's up to you. All of them basically should work. And Niladia's question: is it like VMware Workstation? Yes. So VirtualBox is for Linux, and for Windows you can try VMware, and then you can basically have VM virtual machine images that you can basically open in that VMware station. So yeah. So we know this thing that we have 12.4 TS 12.4 LTS Ubuntu, which is again a version of Ubuntu. Yes, so we are. I also have the same version, Vinod. So we'll work with the same version. Suman has a question. VMware also available for Linux? So VMware I have seen mostly people using on Windows. So I think it should be available, but VirtualBox is definitely available. So and Niladi says that it is. So I think it is. Okay, so basically what you do here is first of all you click on new and you give the name. So like I have named NN1. So let's just for the sake of looking at, we say NN2, and then you give the type of Linux that you want. So I say select Linux because I want a Linux, and then you can say what flavor of Linux you want. So if you want to do Ubuntu, you can do Ubuntu. You want to do Red Hat, you can do Red Hat. And if you want to do CentOS, then you can just say it's a 64-bit Linux. So you select that. So in my case, I will select Ubuntu, and then you have to specify the memory size, at how much memory you want to allocate to this virtual machine, because once it comes up, it's going to take that much memory from your machine. So basically what's happened is your physical machine is say 8 gigs of RAM. Then you have to see, basically decide and see how much RAM you want. For example, we can leave it 2 MB, or we can further increase it. So you can make it like 1.4 MB, or sorry, 1.4 GB, or you can make it 2 GB, 2048 MB. So it's up to you. So basically you select the memory size. So I'll go with a basic minimum size because I already have few VMs here. So, and then you have to say whether you want to create a new virtual hard drive. So, or if you want to use an existing. So basically you can say new, and then you have to say how much file size you want to allocate to your VM. So based on your hard drive, you can say it suggests 8 GB. So I usually let it 8, because if you have say 400, 500 GB hard disk, then 8 GB isn't that bad to use. And then you have to select the hard drive type, so which is VDI, which is just going to work with VirtualBox. But if you are making some virtual machines which you want to take to VMware, in that case you should use VMDK, because then VMDK is compatible with both VirtualBox as well as VMware. So I usually select that. In case I have to switch from say Mac to Windows, then I can just take my virtual machine with me. And then at size, we say dynamically allocated. So if you say fixed side, it will just take 8 GB right away. But if you say dynamically, so as and when your virtual machine stores data and you have more requirements, then it will basically keep on taking the data from your physical hard drive. And then you just say create. So you'll see that it will create a virtual machine which is powered off. So now you can look into the settings and basically change the settings. So anytime, even if your machine is running, so whenever a new virtual machine is created, it's always going to be in powered off state. So you have to basically configure all the settings, and then you have to basically turn it on, which is when it will, you have to basically click the start button, and then it will go in the running state. So what you can so we can see a few things here. So if you go under system, it has the memory that we decided. So you can still change it, or you can reduce, decrease it based on once you run it, and then you see there are some changes needed. And then the boot order which you should use. So that's something that we will briefly look at. So if you look at storage, it tells the storage. So we selected VMDK and we said 8 GB. So it has 8 GB. Actual size right now is just 1 MB, because it doesn't need 8 GB right now. It's just newly created virtual machine. And then dynamically it is going to add data as and when this VM has requirements. So, and then there is this controller. So this is where you basically you specify, controller is where you specify what kind of OS you want. So in my case, you basically click on this thing. It will tell you that you basically you have to download first of all the kind of OS you are planning to install. For example, I downloaded an image for Ubuntu 12.04, which is what I guess Vinod also has, and I basically am using this. So basically, you again do the same thing. You go online and you look for, say, Ubuntu download. Uh, so it can take you to download Ubuntu, or if you go back, you can select right from here 12.04 LTS long-term support. Basically, they're going to support it for a few years. So you basically have to download it from here. So what you will do is, these are all the steps basically. Um, so this is for telling the installation, and somewhere here there should be a link to download. Actually, if you go back, that's installed, so I clicked the wrong link. So you have to go to download, and this is where you click on this desktop. So we are not going to do Ubuntu server or cloud. Similarly for Red Hat or CentOS, we are not going to do servers. We are just getting a desktop version of the OS. So you click on that, and then you choose the flavor, 32-bit or 64-bit, and then you just click on this, and it will basically pop up a window and start downloading. So it will say if you want to contribute to them, you can just say, like, in case you don't want to, just make it 0. And then you just click download. So it will ask you, it will basically, a pop-up will come up, will say where you want to save it, you want to open it. So you just click on save and it will start downloading. So since I already have this image, so I won't do it again, but just wanted to show everyone how you can download. So similarly, you can go to CentOS, you can download Red Hat, so it works with all those flavors. So in this case, I'm going to basically select my 32-bit image. So now basically it knows that this is the OS that it needs to use whenever this VM is started. So, and then if we go back here, the boot order, since we don't have floppy and we are saying use the CD that we just added here as a CD. So we are going to basically just move this up so that it doesn't try floppy, fail, and then come up. And so once you do all these things, then you can also take a quick look at network. So it has few options. It has NAT, it has bridge adapter, it has host only adapter. So basically what this does is, when you select NAT, that means it can just talk to outside world, it cannot talk to your host. And when you say bridge adapter, that means it can talk to the host machine. So in my case, my Mac is the host machine, and uh, and the guest is this virtual machine that I'm trying to create. So when I say bridge adapter, then I'll be able to go to basically the um my host. From my host network, I'll be able to go to this VM. So that's why it's good to select bridge adapter, and uh, and then if you don't want to talk to the host, and then you can also say host only adapter, so the only host can basically connect to the VM cannot connect to host. So Akash has a question: do we need to download 32-bit or 64-bit? So basically, if you see here, Akash, that it gives you options, so you can see that which one do you want, and it also tells you that. So it says that you can choose 32-bit for machines with less than 2 gigs of RAM. So if you are have like having a small machine with lower RAM, then you can go with 32-bit. So in my case also, I'm going with 32-bit because I'm running a lot of virtual machines, so I don't want to load my system and then it just stops working. So Akash's VirtualBox screen's not updated. Actually, it is updated. So like this is the machine, right? So if I go here in the settings, and you can see I did a change under network. So I changed it to bridge adapter. It has bridge adapter. Under storage, I changed it to use Ubuntu. So that change is also there. So it gets updated. Once you click on OK, it is updated. So it's still in Ubuntu website. Still in Ubuntu website. No, basically, Akash, I haven't downloaded it because I already have it. Because if I download it, it's going to take time. So before this session, I actually downloaded it. So that's what I'm using here. If you see Ubuntu 12.0.4.3 desktop IE386 ISO, which was 707 MB file. So I downloaded it, and now I just configured my virtual machine to use this, basically right here, to use this OS as the OS for this virtual machine. Yes, so Niladri is saying based on whether you want 32 or 64 depends on what hardware you have on your machine, and depends on your, Suman is also saying it depends on your system and the CPU version also. So how many VMs do we need to create is another question by Vinod Kumar. So again, it depends on your system. If it is like a small system like 8 gigs ram or 4 gigs ram, then you might not be able to create a lot of virtual machines, because if you see that we are giving 2 gigs of ram or 1 gigs of ram to every virtual machine. So if you make say 2, then you're out of 4 gigs, 2 gigs is gone. So it depends on how much memory you have and how much disk space. So disk space is usually not a problem, it's more about memory, because it is going to take the memory out of your physical machine. So if you have a 8 gig machine and you create two 2 GB virtual machines, then 4 gigs is gone. So that's the only, I think, consideration that you have to take. So what you can also do is make it like low memory kind of virtual machine. Like in this case, I said just 512 MB, so that's like half a gig. So in that case, you can have multiple. So Niladis is, say if you have 16 gigs RAM, then how many should we create to do the testing? So yeah, like in my case, I have 16 gigs. So I have created one name node, and I'm also creating one data node. So you can basically, if you have 16 gigs, then you can definitely play around and have quite a few virtual machines. So just make sure that in case you see, so anytime you see your system like getting slow, what you can do is you can just stop that um, virtual machine and come back. So basically come back to the settings here and go to your storage, and change, system, and change the memory from here. So if you initially gave say 1 gigs, you can reduce this to 512 MB. So then it will just take 512 MB. And when it's restarted again, it will only use this much memory. So that way you can also play around and change. It's not that once you created them, you cannot change them. You can still edit them. The only condition is they need to be in the powered off state. So, okay. So now let's go. So Vinod has saying 3 is enough. Yeah, so if you create like 512 MB RAM, then you can have one for name node, one for data node, one for job tracker. Or if you have smaller machine, you can just combine all three of them together. So which is also fine. In that case, you'll have a standalone installation, or a sudo basically kind of installation. So basically that's what I did by this name, my NN1 basically is a VM that I created for name node. So if we see here in my settings, I created it as I have like 2 hard drives, each of 8 GB here, and I have in my system I created with 2 gigs of RAM. And in terms of controller, it has this image. So, and in network again, I used for the timing I said bridged, but NAT, but it would be bridged. So that's how basically we are going to create them, and then you just basically start them. So now it's already running. So if you say show, it will bring it to the top, and then it will show, take you to the screen. So first time when you do it, it will basically install the OS also. So for example, in my case, I is set in this one, I said Ubuntu. So it's going to basically install. So it's going to take some time for the first time. So that's why I installed it before the session. So now I have this VM, and then I have Firefox here. This is Ubuntu desktop basically. And what I can do is I can open a terminal here. So for that, you basically on Mac, you press Control Alt and T, it opens the terminal. So you can see that I have certain things here. So what I did was I downloaded a Hadoop binary so that I don't have to do it in within the session. It takes time. So for that, again, you go back here and you can again say Hadoop 0.20.205 download. So it will take you to this index of things. So here you will see all the Hadoop releases. So in case you want to go to any specific one, you can go this from Hadoop 0. So from starting from 2008, you will see all the Hadoop releases. So I am going with, for Hadoop 1, I'm going to use this list. You click on here, you will see there are RPMs. So what we need is for our installation, we need this bin.tar.gz. So that's the file that you need to download. So which is the file basically that you see I have here. So I just downloaded it to my desktop. So you can also just basically go here, and once you again you click on it, it will start the download and you can save the file. So now we can see that so when you do a Hadoop installation, you have to take care of certain things. So Niladri has a question: what are the basic VMs that we need to create as part of Hadoop infrastructure at minimum? Yeah, so basically, if you look at the minimum, we can create a name node virtual machine. We can create one for job tracker, and we can create one for data node. You can also combine all of them together based on your system, because a lot of people might not have a 16 GB Mac kind of system where you can have multiple VMs. So in that case, you can just basically combine the VMs together, and you can have both name node and job tracker on one VM and data node on another VM. So yeah, so you can play around with that. So three VMs, yeah, so basically you can make three, or you can even make it two. You can have, just for your testing, you can even have name node and job tracker on one VM and data node on another VM, or you can even combine all three of them together, because now we are just basically looking at the configuration files and doing the installation. So it's, the goal is to basically know what are the main configurations, and once we are at a point where we understand what configuration is needed for name node, what configuration is needed for data node, then we can discuss about when you have multiple machines, then what would happen. So that would again be our future modules. So Nilad is saying, is 16 GB supported on laptops these days, even lower ends? Yeah, it is supported, yes. So Raghunath has a question: how the Hadoop tar is copied to the virtual box? Yes, that's a good question. So in my case, what I did was that you can basically, what you can do is you can copy the name of the tar file to this file at the end, and then you just copy all of it together, and then you can basically do a wget on that. So wget is basically web get. So you basically can do an http get, and you type the url with the complete address, and then it will just start download directly in your VM. So you don't have to copy it from anywhere, or you don't have to basically do a copy. So that's something, that's a good point. So we'll see that also. So before that, let's look at few things. So so right now, because this is just a virtual machine and it had no name, so you have to SSH. You might have to do a IP address using your IP address. So what we are going to do is we are going to make a host name. So what we will do is we'll run a hostname command and give this machine a name like nn1.cluster1.com. So I have to be root for that. So I'll do sudo su, enter my password, and then I'll run hostname nn1.cluster1.com. So now I have given this machine this name. So you can give it any name that you want. So I just gave it a name for testing purposes for our basic cluster. So when you run hostname command, you will see that it gives this host name. So so now the host name has been changed for this particular session. But if you want to change it for, like, when you log in next time, it should still have this name. So you basically need to go to ITSI hostname file, and you have to add the host name that you want to have here. So now this host name will be persistent. So whenever you stop your VM and come come back again and start your VM, it will still use the same host name. So it's good because otherwise you have to give the IPs in all the configurations. So that's something that you will see that as you all, some of you are Linux administrators, and you have seen that every machine has a host name usually, because referring it by IP is not what most of the people do in production. So there'll always be a host name assigned to a machine. So Suman has a question that we can do the drive mapping as well from host to VM. uh, so you can do drive mapping. So basically when we look at the VMs, we are usually so what we are seeing is that it is creating a different drive for it, right? So if you go here under storage, you can basically create these drives. So sorry, this was the VM, that the drive that we initially created. So what you can do is you can click here and you can even add more drives if you want. So you can say add hard drive. You can create a new disk. Then again, the same thing that we did last time, you create VM DK kind of hard drive, and then you say dynamic, and then you can say another, say 2 GB on this file, or 500 MB on this file, and then you can create. So this will also become part of this virtual machine. So now you have two drives, and then once you basically have your VM up, then you can mount these on the virtual machine. So basically, this is like, so Suman's question was that can we do drive mapping as well from host to VM? So we are not doing it host to VM. We are just creating some drives for just this particular VM. So I think you should be able to do it, but we don't really need it for this installation. So we are not basically doing it now. But I think I'm sure there should be way, because you can communicate from host to VM and VM to host. So there are ways. So if you look up under the VirtualBox documentation, there'll definitely be ways to do that. Okay, so let's go back here. So basically what I'm doing is I'm changing this ITSI host name file. So basically to this host name. So this is for Ubuntu. For CentOS, if you see, there'll be another file, and so you have to make sure that you change it. And then another thing is ITSI host file. So you have to make sure that whatever IP has been assigned to your VM, you just add an entry for that VM with this host name here. So this is name node. So basically we are saying that the IP for this name node is 192.168.56.101. So how did we find that? Was by running if config that dash a. So if you see here, this is the IP that it says for this machine. So that's how I found out that this was the IP, and then I added in ITSI host file 192.168.56.101. And so now that's something that you will see in every production system, that all the master as well as slaves, so ITSI host file will have one such entry for all of them. So this is for name node. Suppose you say DN1 for data node, so you will enter an IP and data node host name. Then you'll have for job tracker also. So basically in a Hadoop system, all the ITSI host files are kind of replicated across the cluster, and all of them have an entry for every component in that system. So there'll be one entry for host name for name node, host name for job tracker along with IP, and host name for all the data nodes and their IPs. So that's something that usually is always done when you set up a Hadoop cluster. And and then now that we have, if you guys remember, I told you that when we create a VM in the settings, we set up this adapter. um, let's go under system and sorry, network. So we said bridge adapter, right? So basically what this means is now I can talk to my host machine. So if you can see that once you install VM, you go in there, it's very difficult to work in this VM. So what you do is basically you set up this bridge adapter, and you have to you will basically then be able to just open a terminal. So for people who don't know terminal, this is basically just to log in, do an SSH client basically. So for Mac, there's a terminal. For Windows, we have PuTTY, PUTTY, where you basically just install PuTTY, you give a host name, and you you can select SSH to that host name, and you can just directly log into that host name. So because working in virtual machine is kind of difficult, so that's why we basically will have set up this bridge adapter. So once you set up the bridge adapter, then you should be able to just log in from your local machine, and you should be able to just go directly. So for example, what I'll do is I'll try to log in again. So what I did here was I logged in as John at this IP 192.168.56.101. So once I do that, this is I give my IP, and now I'm able in this machine. So now I can basically do things directly on this machine. I can copy paste from my host machine, because in this case, paste is very difficult. And after some time, your mouse doesn't really work if you're using a mouse. So on your host machine, everything is going to work because that's your host machine. So that's something that I will suggest all of you to do, this kind of setup that we do. So Niladi has, for a large cluster, it's not recommended to use a DNS instead of its host. Yes, definitely. So we do we all the big cluster, they'll definitely have a DNS where they will specify the name server, and that will basically give the resolution. But still, the entries are still added in its host. So we definitely should add the entries in its host also, because some of the Hadoop daemons, they also read its host and do the resolution. So basically, apart from DNS server, we also need its host to be updated. Okay, so basically now we have this local machine. So now what we can do is we can get started. So there was a question by Raghu, that how do you copy the jar to VirtualBox? So now that we have this thing set up, so now you don't need to do anything. So only thing is that with Ubuntu, this might not work. You might have to do an installation of a package. So you might have to run something like apt get install open ssh that server for this kind of terminal to work, because this package, so what when you install the VM, so this is like a basic VM image that is coming, and it doesn't have a lot of packages. So this OpenSSH server package on Ubuntu is needed for this mapping on host, basically login from host to work. So if it doesn't work, then you should try to do this install OpenSSH server, and that should basically install. I installed it before, so it's already saying it's updated. But if this doesn't work even after setting the bridge adapter, then you should definitely install OpenSSH server to connect from local machine. Yes. Yeah, that's why we are. So Suman has a question that in Windows we have PuTTY. What is equivalent in Linux to connect from local machine? So basically, this is a Linux machine. This is a Mac, right? So here we have something called terminal. So that comes as a utility as part of Mac. On Windows, we have PuTTY. So you can, based on your system, you can use. And then you can also, then Niladri is saying you can also SCP to transfer the file from host to the VM when bridge network is set up. Yes. So that's why it's important to set up the bridge network here that we did in um, here. And one more thing is, when you do a network, you might have to do a host. Sometime you might have to do like a additional adapter which is just host only, in case this thing doesn't work. But I think after you install the OpenSSH and you have a bridge adapter set up, then basically you should be able to log in. So that's how I basically just logged into the system. So now we have to basically, we have two main things that we need for Hadoop to work. We need to have Java, and then we need to have Hadoop. So Hadoop binary, we just looked at that, how we can do get it. So now what you can do is, now that we are on our host machine, you can just do a copy of this, and here you can run wget of this. So I'll try this in, say, a different directory, because I don't want it to overwrite this. It's going to take time. So maybe that's, if I go to downloads and I run wget, you will see as soon as you type it, it will start copying it. So now you don't have to go anywhere else, just copy that URL and run wget. It will do a webget of that file that you are trying to download. And Nilad is saying for Windows, WinSCP can be used. Yes. So WinSCP is another tool that is free, and it is used to move data from one host to another. So yes, we can use WinSCP also. And Putty and Nilad is saying Putty emulate terminal on Windows. Yes. So Putty is like equivalent of terminal on Mac for Windows. So once we have this Hadoop binary downloaded, so next thing is getting Java. So 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 I think for every system you can basically look up. You will find different ways to download Java. So for Ubuntu there are different steps, and for CentOS there are different steps. So if you look at Ubuntu steps, we just have to basically uh, do some kind of a repo. So what you have to do is you have to run the command like add dash apt dash repository, and then you have to do ppd colon web upd 8 team slash java. So basically you are just setting up a repository to get the download. And then I have to be root, so I have to do sudo su, then I run this command. Okay, it is giving me error that ppd web upd 8 team is invalid. Okay, so let's see. So again, I mean, if you have any such error, you can always go here and you can basically look at it. Ubuntu, say Sun Java 6 on this. So you can see that somebody would have already worked on it, and you will see that how people do it. So if you see here, this is the way. So what this guy is doing is just need to do these three things: ppa web upd 8 team slash java. So you run this command, and before that you have to do basically update your thing. So that's, I think that's the thing I was missing. So basically this is just Java installation on Ubuntu. If you have CentOS, you'll do again Java installation. So because for Hadoop we need Java, so and you need to do that. And I think there should be something on learning management system also on how to do this. So that would be another good place to look at it. Okay, so now that's done. Let's try to do add apt repository peep. Oh, okay. Did, and can anybody tell me what was the issue that what was the thing that I was doing wrong? I was not adding a, it was a, I was doing d. So yeah, so those are kind of things that sometimes happen. So now it is basically trying to get the Java to the local machine. Yes, Raghu is correct. I had to do PPA. So it's going to take, so basically it is getting Java 7, is going to basically get the package for Java 7 from webupd8.org and going to add it to my local machine. So let's take few, should not take a few minutes, but like less than a minute. Okay, so it's done. And now you again just run this apt get update, which is basically updating your repository. So Ravinder Singh, I guess we have to have internet connection from where we are executing these commands, right? Yeah. So basically, so that's what you have done, right? You have established a bridge adapter. So that's why that setting is important, because once you establish bridge adapter, then you should be able to connect to internet. Okay, so that step is done. So now we'll basically just go ahead and install. So we'll say Oracle Java 7 dash installer. So where basically that's a package in the previous ppd command, that ppa command that we run. So now we'll just, this command will basically just install. It will ask you, do you want to continue? Say yes. And now it's getting Java. It is asking you to approve the license. So you just say, okay, click enter. And then you press your left arrow and then again say yes. And it will start basically installing the Java. So Niladi has a question. Can you please explain the repository creation process briefly? Yeah. So basically, so as we know, like in every system, there are like RPMs, which are packages. So you basically, in case of Linux or CentOS, you get those RPMs and you install those RPMs. So in case of a system like Linux or CentOS, you will run a command like RPM dash IVH and the RPM name. So for Linux or CentOS, you will definitely, you can just go directly to Sun Java and get the, so what you can do is Java 6, say Oracle. So if you go here, Java downloads. So for a Linux or CentOS kind of system, you just go here directly and you do the downloads. So you do Java to SE. So you go to SE kits and you see there are different uh, kits here for different patches of Java 6, Java update 26. So you just select any Java, any version of Java 6 is fine. So you just install JDK 6, and when you try to, for example, if I try to click this one, JD Java S kit, it will again tell me what kind of versions are available. There's one for Linux, there's one for Solaris, there's one for Windows. So you just select the one that you want. So if it's a Linux, you will basically get an RPM which is X 64 kind of RPM, and so you basically, yeah, just select, click on this, it will again start the download. But for Ubuntu, you have to do the steps that I just said. Yes. So the question from Ladi, is this process specific to Ubuntu? Yes, this is just for Ubuntu. Niladri says that I am breaking up. So is it clear now, Niladri? So basically, what I was just showing here was that how can you get Java for systems other than Ubuntu, in for like a Linux system or Solaris. So for CentOS, you basically just go here and you basically download Java directly. You just accept the agreement, licensing agreement, and then you can just start downloading. So okay, so looks like people are having some issue with my uh, thing. So is it still breaking up? Um, okay, so let me just say this once more, that for Linux or for CentOS, we can also in the meantime look. Okay, so this has finished. So it says Oracle JDK 7 installed. So what we were discussing here is that for Linux or for CentOS, you basically just have these file sizes and you just install the JDK version directly from here. Okay, so there's something, I guess, wrong with my headset today, that a lot of people are having some issue. But yeah, I'll take a look at it, and uh, so hopefully we won't have this problem in next session. Okay, so now we have Java installed. So now what we can do is we have to basically include this Java in our path. So we right now we see that it has been installed under user lib Java JVM Java 7 Oracle. So but if we don't know, then we can always run a command like find. So you run it on root and you say minus name and you say Java and print, it will tell you where all it has seen Java. So if you see, this is where it sees Java right now. So that's the path where Java is in our system. So what we have to do is we have to add this to our profile. So what we can do is either we just export the path here. So we can do like export path is equal to current path and add the new path that we want. So basically what I'm saying is user lib JVM and Java 7 Oracle. So either I can do this, or so when I do this, basically what it means is that it is just for this session. And when I come back again, it won't be there. So if you want it to stay there next time, you don't have to do it manually. So in that case, what you do is you run it in your profile. So this is the root system. The user is root. So that's another thing that we should see, that when you run Hadoop, then you basically don't use a user like root. So Hadoop has his own users. So people use a user like Hadoop or HDFS or MapRed. So what we will do is now we will add a user. We'll add user Hadoop. So now if we run ID Hadoop, basically we'll see that there's a user that is created. So ID is basically command to see what user is there on your system. So you run ID with any username, it will tell you whether that user exists, what is his UID, what is his group ID, what are the groups that this user is part of. If you say run it for ABC for some user that does not exist, it will just say no such user. So what we are going to do is we are going to do all the Hadoop work as user Hadoop. So what we can do is we can su to Hadoop. So now we have Hadoop users. So if you see here, it says Hadoop at NN. So that's the user. Previously, it was root at NN1. So now my user is Hadoop. So I have created this user Hadoop, and now I'm going to use everything that I'm going to set up. I'm going to use this particular user. So now when I was talking about setting the path, so I can do something like this. So then it will add it for this session. So path basically means that now it is telling the system that add this Java version to the path. So that means when any of the Hadoop daemons need to know about Java, they will just look at this environment variable and they will find the location of Java. Otherwise, it might fail. So that's the reason we have to add things to the path. So that's not just for Java. You a lot of times you will see that there's LD library path where you have like custom libraries, those need to be added. So this is how we do it. And if you want to make it consistent, basically you go to your bash profile. So if it doesn't have bash profile, you'll just say bash underscore profile, and then you just add here this thing that for path, basically add, take the current path. So when you say path is equal to dollar path means current value of path. What is the value right now? So we keep that value as it is because we don't want to remove the things that are already there. And then in addition, we say colon and then the new path. So that's how you basically add path. So we will add this path to the system. Okay, so looks like we are not at the right location. So home Hadoop does not exist. So we also have to do that as a part. So we'll make home Hadoop directory, and mkdir is the command basically to create a directory. And then we give the ownership of this directory to Hadoop. So we'll say chown, which is change owner to Hadoop, and then I'll also give Hadoop colon Hadoop, basically user and the group for that directory. So it's home Hadoop. So now if we'll say slash home, we have two users, one is Hadoop and one is John. So the directory for Hadoop is Hadoop. So we will now su to Hadoop user. So now we are under this directory. So if you see, previously I did su Hadoop, now I did su dash Hadoop. So that's basically the difference is that when you do su Hadoop, then your bash profile is not basically sourced. When you do su dash Hadoop, then it will basically source your profile, and it will basically, whatever you add to your profile, it will add, it will basically bring in the environment. So now what we have to do is we need to create a bash profile, and then we need to add our export variable here. So I'll just copy it from here. So I added this as my path variable. And so if you have to see this, so bash profile is basically a dot profile dot file, which means it's a hidden file. So you have to do something like ltra to see this file, then you will see the file is there. So now that you have done this, so now if you log out of this session and come back again, the path will basically have this value. So to see the current value of path, you can run something like this. So you see it's not there because we haven't yet run this bash profile. So you can also source this bash profile. You can do dot space the path, which is home directory, and then run dot bash profile. That will basically now run whatever commands are there and in your bash profile and export it. So now if you echo this, you will see that we also have an additional Java path. So now if I run java dash version, it should tell me the right Java version that I have, which is 1.7. So now our Java is set up. So that's one prerequisite that you need to have. You need to have Java set up. And then the next thing is you need to, now we can basically start with the Hadoop installation. So let me get back. And so I have Hadoop tar uh, in the here. So what I'll do is I'll move this file to slash home Hadoop so that we can do everything from Hadoop user. And then I'll again give the ownership, because if I do ls, it was owned by John user previously. So now what we have to do is make sure that Hadoop, if we have to run it as Hadoop, we need to change the owner again. So I'll again run the command chown, and I'll do Hadoop colon Hadoop and home Hadoop and run this command. So now we have everything that we need under Hadoop user. So now we'll not do anything as root. We'll do the complete installation as Hadoop user, run the bash, then echo path. Now we don't have that, so you need to source it. So now we have that path. So Java is there. And now if we look here, we have this jar that we need to use. So now what we can do is we can create a directory called, say, Hadoop, where we will do the installation. And then what we can do is we can untar this directory, this basically tar gz file into Hadoop. So basically tar gz is like a tar and compressed file. So tar basically is like a collection of files, and they are compressed with the gz format. So that's what is in this file. So what we can do is we can move this file to Hadoop directory, and then we can do everything from Hadoop directory. So now we will basically extract the data from this star file. So we'll do something like tar dash xvf. So x is extract, v is verbose, and f is force that we run it. So once you do that, you will see that we'll have all the files which are with this version of Hadoop, and it goes under bin directory. We have all the binaries and under, so let's now look at, so we have now extracted. So basically what we have done is kind of in terms of window, we have unzipped the file, and now we have this Hadoop folder. We go in this folder, and in this folder we have basically Hadoop libraries, we have binary files, we have configuration, and we have some test jars that come as part of Hadoop. So so now what we can do is we can basically look at some configuration files, and then another thing that we can do is some people also create a link for this, but for the timing, I guess we can start with this. So let's look at the configuration file. So now this is a name node, right? So if we go under configuration, there are few files here. So if you will see, there are few files here. So we'll go through each of these and discuss which are which of these files are needed for which of the basically components. So what we can do is we can go back to the slide here. So this is where we left from our presentation, that we have the configuration files. So if we look here, so we have these files here now. So we have Hadoop env.ss, which is Hadoop environment file. So it has all the environment variables that are used in the scripts to run Hadoop. So whenever you run any Hadoop command, this file environment file is called before that. So we'll take a look at this file. So let's take a look at this file. So when you look at Hadoop environment, so you'll see that there are all these parameters here that we have to basically take a look at. So what we have to is point first of all to the right Java. So that's the first thing that we will do. So let's look at the Java path from our bash profile. And actually, we should make it, instead of bash profile, we should make it bash rc file. That's the file basically that we have. So that's the path. So in your Hadoop environment file, that's the first thing that you have to do. So as you can see right now, everything is commented. So okay, so we know this saying, please give me a 5-minute break before we go. Yeah, sure, let's do that. Yeah, so I think this is a lot of heavy stuff. So yeah, I'll give 5 minutes to everyone to get refreshed. So we'll take a look at this file after a few minutes. So yeah, sure. So in case anybody has any questions, you can definitely ask in the meantime. So Raghu has a question. Is it possible to make the window a little bigger? Oh yeah, sure. So you mean the window size or the size of the letters? Okay, maybe let me see. If I go here under settings, edit, view bigger. Okay, so let's do it a bit more bigger. So hopefully that should be visible now, Raghu. So Narsima has a question that is there a document that explains basic Linux commands? Yes. So if you go to learning management system, you can see that in our first module we had Linux basic commands. So you can definitely look at this. There's a presentation, so you can play it, download it. So that should help you get going with the basic Linux commands. So yeah, so I mean, you don't need to know a lot of Linux commands, but if you know, it's always good because most of the production installations for Hadoop are going to be on Linux. So that's something that it's good to know. So Vikrant has a question that are you working as a Hadoop administrator or architect as a consultant? So Vikrant, I have worked as Hadoop architect. I have done Hadoop development, and I'm also taking care of Hadoop platform at my current job. So I have done variety of things. I have, as I told yesterday, that I have done Hadoop application development, and I have also worked on creating a connector that gets data on Hadoop. And then now I'm working on platform, which is like core Hadoop 1.0 and 2.0 platforms, and the tools that are getting built on top of Hadoop, like Impala and Shark. So basically, I work with my teams to look at those tools and do POCs on those tools and see if they are fit to be installed in production. Then I also take care of Hadoop clusters at my job. Okay, so we go back. Okay, so Niladri is saying is just untarring the compressed file completes the installation. So untarring basically does not complete the installation, but it gets all the files that we need for the installation. So now we are going to basically configure the cluster. So these are the files that we see. So we are going to basically modify these files, and then we are going to be, and this is going to be like a discussion in next module. Also, we'll start today with looking at the basic files, what we need to modify, and then we are going to continue basically working on getting adding more and more configurations as we learn more. So it's going to be spread out across next 2 3 sessions. So Raguna has a question: is Solar a part of Hadoop ecosystem? So Solar is not part of Hadoop ecosystem, but like Shark and all this system, it is a system that basically can work with Hadoop, and I think a lot of people are looking at it, and it's getting a lot of traction. So it's not a part of Hadoop ecosystem as of now, but it might become like like Cloudera has included like a Shark application in their Hue, and so as and when things become more mature and they keep on adding, so they keep on becoming part of Hadoop ecosystem. Like Facebook has just released Presto, and everybody's saying that Presto would become part of Hadoop ecosystem soon. So that's the thing, that slowly these things are like as they mature, they are adopted by different distributions like Cloudera or Hortonworks, and then they make it part of their um, platform and their distributions of Hadoop. So Vikrant, is what profile are companies looking out? Is it mixed like development and admin or special administration jobs? So if we look at, so there is requirement for both Hadoop development as well as admins, but both are, I think, equally seeked jobs, because it's not good. It's not easy to find a good Hadoop administrator because there are a lot of things to do in Hadoop. So it's not just installing, you have to configure, you have to know how many nodes you want, how will you capacity plan your cluster, how will you monitor your cluster. So those kind of things all basically come part as of a Hadoop administrator. So he does all those kind of things. So, and it's a distributed system, so it's not easy. So Hadoop administrator is a very sought after skill, and especially because everybody's adopting Hadoop. So they need Hadoop administrators, because Hadoop administrators are different than Linux or Windows administrator. They need to know Hadoop more than Red Hat or Java or those kind of installations. So that's why I think both are having their own importance, and both are like really sought after uh, profiles nowadays. So Narsima asks, how is the job market for Hadoop administrator in US? So Hadoop administrator market is, I guess, good everywhere right now, as I just discussed, and I also told the reason why. So I think it's a very emerging market, and real good Hadoop administrators are needed everywhere, and it's not easy to find them. So did I say? And we'll learn those in the training. Yes. We are going to yeah, we are going to cover all these aspects of Hadoop administration in this training as and when we go further. So today we are just looking at the basic files, and once we get familiar, once everybody after today's sessions, they go back and they basically start doing what we are doing today, install Hadoop on their machines, and they get all these files going and start the daemons, all the daemons that we have in Hadoop. Then we're going to look at more configuration and get the configuration going. So Ravindranath has question as, are there openings for Hadoop admin with no experience? So mostly mostly companies, they want somebody with practical experience. So, but then you can start with, and if you have a very good grasp of the concepts, then you can always apply for a job. And if you the thing that you can do it, they will look at it, because there are not a lot of good Hadoop administrators available in the market. So definitely, if you can prove that you know Hadoop and you can do good administrator, so people will hire, like freshers, they are hired, right? Because they seem promising and they are able to do things. So yes. So Gandhi has a question. Can you please throw some more light in which order the name node, edit logs, secondary nodes get updated when a modification happens to a data block in a data node? On a high level, what Gandhi has to say is that I understood is that when there is some update happen to a data block, the info is passed back to both active name node and standby name node, and active name node updates the metadata inside the node, and it updates on edit log. That's correct. And the secondary name node by the time got the info from data node. So secondary name node is not going to data node. Secondary name node, which is the checkpointing node, will always get all the information from name node. So it doesn't go to data node. So only name node is basically interacting with data nodes. So secondary name node is not interacting with the name node. So name node gets the state from data nodes. It updates its metadata of file image and file system image and edit log. And secondary name node, which is the checkpointing node in case of Hadoop 1, will periodically fetch those metadata and just save it on its local machine. And when we go to Hadoop 2.0, then we will have a setup where you'll have a shared filer, or you have a quorum based storage where the active name node would be writing to edit logs and to file system image, and the standby name node would be just reading it and just updating its own copy. So hopefully that helps Gandhi to understand. So Raghunath says, after this training, we can have enough foundation to attempt for CDS administrator. Yes, definitely. So once you have all the good concepts and you do the quizzes, you do all the assignments that are given, and you try all the documents that talk about installation configuration. So definitely you should have a very good understanding, and you should be ready to do the CDH administrator exam. Yes. So Gandhi is sorry, it is not secondary name node. My point is standby node, right? So Gandhi, I explained both for secondary name node as well as the standby name node, and then yeah, we are also going to cover this in detail in our rest like coming up module. So yeah, so you can all read about it, and then we are also going to cover it in our next session. So So Niladri is saying that there is module present in your LMS name with old batches class recording. Okay. So Niladri is actually contacted I think our admins at Edureka, and they said that this module is present my in your LMS name with old batches class recording. Okay. Thanks Niladri for finding this information. Okay. So looks like everybody is back now, so we can go back to our configuration. So So, so this is the first file that we are looking at, which is Hadoop environment file. So first thing that we have to update is make sure that we have the right Java version. So what I'll do is get the same Java from the bash RC file, which is this, and we will add this to Hadoop. So everything is commented right now. So basically you have to, first thing you have to do is uncomment this, and then you have to replace it with the Java version that you have. So previous was 1.5, but we are using 1.7 version, which is the latest version. So we are going to update that. And and then you can also see that Hadoop heap size. That's another very important parameter. So this is the heap size. So Akash is saying, what is the difference between Open Java and Oracle Java? So at Oracle Java is Sun Java, so which is I guess used in most of the production systems, and most of the distributions or tools are basically kind of certified with Sun Java because that's standard. So Open Java is like not, so people don't benchmark their tools against Open Java, so most of people are going to use Sun Java. So that's something that that's why it's always suggested to use Oracle's or Sun or slash Sun Java. So that's why we are also going with this Oracle Java. Okay. So Akash, which is preferable? So yeah, so it's always Oracle or Sun Java. So the next thing that I was talking about was the heap size. So if you can see that the default is 1000 MB, that is 1 GB. So that means if you use this Hadoop environment file as it is, you don't change it, it will always start any Hadoop daemon with 1 GB of heap size. Basically means 1 GB of RAM. So any Hadoop process that starts on this machine is going to use 1 GB of RAM. So if you want to change this to a bigger value or smaller value, so you can again uncomment this. So basically I'm pressing X to delete this. Now this value would be used. So since we have a small virtual machine, we can change it to like half a gig, like 512 MB, which is half GB. So we can do that. And then you can see there are some other options. You have name node options, you have data node options, you have balancer option. We'll see what balancer is as we proceed in our courses. And then there's secondary name node, there's job tracker options. So all these options basically you can specify here. So if you want to basically specify the heap size for name node, so you can add here a value for name node that's minus xmx, which is the Java way of specifying the heap size. So you can add a heap size here for name node, for job tracker, because if you don't specify, then name node will start with this default value of 512 MB. So in all production systems, when people start name node, they always add the option here. So let me quickly show how it will look like. So basically what I was going to do was append. So it will look, sorry. So it will look something like minus xmx, and you can say 20G. So that means you want to start name node with a heap size of 20 GB instead of 1 GB, or instead of half a GB as of now. So so that's what you'll see, that a lot of people change these values in production based on the size of their cluster. So I'll undo this for the time being. Okay, so I think I am pressing some wrong keys in my terminal, which is adding extra line. So what I'll do is I'll just remove this. I just wanted to show that this is how you specify the heap size in Java. You say XMS option and you specify the heap size, and which essentially Hadoop also does that. It reads this file and just runs the process with minus XMS 512 MB. So Nandakumar has a question that from our lab, would installing Oracle Java 6 would be a problem instead of Oracle Java 7? No. So Java 6 is perfectly fine because CDH3, CDH4, CDH4 is basically working with Java 6 and CDH5 uses Java 7. So as Java new versions come out, so basically Cloudera and all the different distributions, they also use the latest Java to certify because they are performance improvements, because Hadoop is built on Java. So if a new version of Java has come with some performance improvements, so when you release Hadoop, if you also use the latest version, then you are going to get some performance improvement. So that's why CDH5 basically supports Java 7, but you can also use Java 6. So that's not a problem. So Rudra Gara has a question that in a typical real-time deployment, what is the heap size? That's a very good question. So basically, it depends on the number of nodes. If you start with say 2, 3 nodes, you might start with like 1 gig of heap, or you start with 2 GB RAM. But when your node size goes to say 40 or it goes to 100, then people go to 10 GB size, and if it goes to more than 100, then people go to 20 GB. So that's why name node and job tracker in a bigger cluster, they will always be on a different node. And so that name node gets all the memory it needs, job tracker gets the memory it needs, because in a bigger cluster, you people are going to submit more jobs and job tracker needs to track all those jobs. So it needs more memory. So that's why in a typical big cluster, you will see that usually people start with at least 20 gigs of memory for name node, 20 gigs for job tracker. So that would be like the estimated size in a real-time production deployment. So Niladri is saying, is there a Hadoop configuration best practice documentation? So Niladri, there are different documentation. So there's Apache documentation, which tells you all the major configuration parameters that you should define for Hadoop. And then we'll also look in our future sessions, there's Cloudera Manager. So Cloudera Manager is another tool which basically helps you with installation, monitoring, and taking care of your cluster. So with Cloudera Manager, you can also install a cluster. So and then it automatically suggests some values based on your hardware. So it's an intelligent tool in that way. So you can do you use that tool, which will tell you basic minimal values based on your hardware type. So those are things that we'll also look. And then in our next sessions, we'll also look at the major configuration parameters that we need to modify for Hadoop system and all the components. So we will take a look at that. So basically, yeah, so this is what I wanted to verify, tell everyone that Hadoop heap size, if you don't specify anything, by default, Hadoop is going to start everything with 1 GB. So if it's a name node bigger value, so you always have to change this value. And then there are all different options here. So these are all like default options. So what we can do is since our Hadoop home is different, so what we can do is we can set up Hadoop home here. So if you see, our Hadoop is right now installed in this directory. So this is where you have Hadoop by bin, and there we have conf. So this is the path where our Hadoop home is. So we will specify another parameter in our Hadoop env.sh and Hadoop environment file, basically, which is under conf directory. So we'll say Hadoop env.sh, and then so it doesn't matter where you add the parameter, you can add anywhere. So for example, if you want to add at the end, I will add a line here, export Hadoop underscore home is equal to the location where you installed your, basically untarred your Hadoop binary. So Vikrant is saying, can we take installation in one step and then ask the questions? Okay, so we are done with this Hadoop environment setup. So we'll save this file. Oops. And now we'll just look at the more. So now this is a name node, right? So for name node, we have to look at the configuration files. So let's go to conf directory, and the first file that we have is core site. So that's the first configuration file that you have to modify for name node. So if you go back to presentation, so it has basic core values, which are like IO settings that are common to both HDFS as well as MapReduce. So name node is one such setting that is basically common to both HDFS as well as MapReduce. So job tracker needs to contact name node and HDFS needs to contact name node. So the most basic thing that we have to define in a job tracker in a core site is basically, sorry, the path of your name node, the name of your name node. So so basically all the configuration files, if you see, they come empty. So you have to basically add a value. So in our case, I just have this value. So what we need to do is go in within this tab, and so in Hadoop we have this property tags. So you basically, this is an XML file, so you specify a property and it is a name value pair. So every property in Hadoop is like a key value, so you specify the basically name, and then you specify the value. So in our case, we are saying file system default name, which basically means the name node. So what we are saying is our name node is the name, the host name where our name node is running is nn1.cluster1.com, and the port that name node is going to run at is 8020, and the URL is HDFS because it's a HDFS file system. So this is the most basic thing that we define for a name node, basically. So whenever we start the name node daemon basically, it's going to look at this and use this to basically bring up the name node. So so this is the first file that we need to change. And then the next file is HDFS site. So in HDFS site, basically we do configuration for the daemons. We specify the name node, secondary name node, data node, based on the kind of node you are working on. So right now we are working on name node, right? So we are going to add name node specific settings under HDFS site. So again, HDFS site, any configuration file you open will always be empty. So you have to add the property tags and the name and values of your properties. So for HDFS, the most important thing that we are going to define is for name node is dfs.name.dir. So that's the name of the property. So which basically tells that location where name node is going to write the metadata. So in our case, we are saying slash data slash nn1. So basically, it's a volume. So disk volume, and this is the place where people define like multiple locations for the name node. They will suppose that you have two disk volumes, so you'll say something like data nn2, and then if you have a filer, you will give the location of the filer, that say shared nfs nn. So when name node basically has to record any change to metadata, it will write to all three of these. So it's always suggested that in a production system, you don't have just one value for this, you have at least two values. So for our testing, we'll start with one to understand this. So we are saying this is the value, this is the um, thing. So this is how you define basically name dir. So we'll save this file, and we also need to make sure that we have this directory existing. So if not, we'll just create this directory. So we'll do again a sudo mkdir -r slash data slash nn. So slash r is recursive. So basically telling that if data and nn are not there, just create all of them. So I have to enter the password for Hadoop. Okay, so that's another thing. We haven't set up the password for Hadoop. We just created the user. So we just do something like password Hadoop, and we set up a password. So I'm right now just saying Hadoop. I have to do it as root. So let's set up the password for Hadoop so that when you are as Hadoop user, then you can basically uh, you know run the commands as sudo. So what we're going to do here is go back to our installation directory, 0 and conf, and now we are going to just create the directory. So it is asking for password, so we just set up the password. So now if I enter the password, okay, it says that Hadoop it cannot do a sudo. Okay, so in that case what we'll do is we'll run it as root, because the main purpose is that this directory should exist. So I'll do data nn, um, so I think it's F option, not R, so I used R option. So let's create the data directory, and then we create this directory, and I'll give ownership of this to Hadoop. And in this case I'll give a recursive so that both data as well as NN directory are owned by Hadoop user, because that's the user we are going to use to run Hadoop. Okay, so now let's go back to our directory, and so now we have our basic configuration set up to run a name node. So now we are able to create. So Nanda Kumaris, did you create a additional mount point for slash data? If so, what is the permission? So in production, yeah, definitely there'll be a mount point, but since this is a virtual machine, so we are just going to use this location for slash data. So I just created slash data nn, and if you see the permissions I gave here are for Hadoop user. So that's what we are trying to do. So now we can actually try starting a name node. So we'll go to bin directory, and we'll see all these scripts here. There is start all, there's Hadoop daemon and Hadoop config. So what we are going to do is we are going to use this script Hadoop daemon, and permissions are fine. So we'll do Hadoop daemon.sh, and then we are going to give basically the process that we need to do, and we are going to say start. So we are going to start, and then we are going to give the daemon that we want to start. So we are going to say Hadoop daemon start name node. So when you do this, it will basically try to start name node, but it is saying that Hadoop Java home is not set up. So in our conf, we did Hadoop env.sh. So Java, oh, looks like they didn't get saved. Okay, let me redo this. Yeah, so basically, if your parameters are not set up, it will tell you those kind of things. So since in Hadoop env, somehow I did not save it, so the Java parameter is not set. So in that case, what I have to do is just set that parameter once again. And then we are going to do the heap size change, and then we're also going to add the okay, the home is there, but for some reason the Java heap size did not get saved. Okay, that's weird. So I'm going to save it again and look at it once more. So now we have the right Java home. So now we can start the name node. Okay, so now you can see that it has logged in this directory. So we can go to this directory, which is our logs directory. So go in logs, and it has created a log for the name node state. So if we look at name node, it will tell that now it has started the name node, but we haven't formatted the name node. So that's the thing that we have to do, is you have to format a name node. So whenever, like a file system, whenever a name node comes up, so before using name node, you have to basically format the name node. So now we will basically do the formatting of name node. So what we'll do is go back to our bin directory, and we'll run Hadoop. So you can see that if you do Hadoop, you will see that there are different commands that are available as part of Hadoop. So so you can see that there is name node format. You can start look at the name node. You can do fs commands. You can run fsck. You can run dfs admin. You can run mr admin. You can run a balancer. So we'll go through all of these commands as and when we get our cluster up. So first of all, we'll do is Hadoop name node format. So we'll do slash Hadoop name node, and we'll say format. So what you will this will do is this will basically format our name node. So okay, so what it's saying is that we started the name node. So we have to basically make sure that the name node is down when we are doing. So what we'll do is we'll do a stop. And now we will basically do a format. And I have to give a dash format. Yes, so that was the thing, that you have to give a dash format. So now it is basically saying that you specified the data directory for name node to be slash data nn. Can I format it and create the name node specific files there? So I'll say yes, and then basically it will. So now we'll see that under data nn, we'll have the image, and we'll have a current directory. So under image, we will have fs image, which is the file system image. And once we have the nodes added to our cluster, then we will have basically the edit logs also, as and when we do things on the cluster. So that this is the basically the place where name node metadata is stored. So this is the file system image right now. And then there is a directory called current data nn current. So if you look under that directory, there we have fs image, we have edits logs, and then we have uh, the version. So if you look at the version, let's briefly look at the version. So this is where you have a namespace ID. So whenever you do a name node format, it assigns a namespace ID. So this namespace ID will now stay for the duration of the time your name node is not formatted. So usually whenever you won't format your name node, like a lot of times whenever you set up a cluster for the first time, you are going to format the name node, and then at that time a namespace ID will be assigned, and this namespace ID will stay here. And once we after this we look at the data nodes, then we'll see that the same thing happens for the data node also, that the same namespace ID will go to data nodes also. And then it tells the storage type that this process is a name node. So this is the version information. And then we have fs image and edits file here. So our name node is up and running now. So another thing that we can do is that we also have a web UI for name node. So whenever you run name node, so if I go here and I try to look at the name node, I can say http://nn1 dot cluster1.com, and I'll say 50070 first. Okay, so for some reason it does not know this IP yet. So what we'll do is, sorry, this host name. So we'll try to replace this with 192.168.54.101, which is the IP for this machine. Let's verify. Okay, so for Hadoop user, I cannot do it. So let's try. Okay, so yeah, so we'll come back to this. So there's a web UI also for name node that starts. So that's the one that we are looking at. Actually, I can also do one more thing. I can say HTTP localhost. Okay, so yeah, so there's a name node web UI. So we are going to basically come. Okay, so we know the same. We can also do IP. Yeah, so local host or IP, yeah, should work. So yeah, so we'll come back to. So basically now we have we'll come back to that. So now we have our name node up. So the way to see is there is JPS, which is Java process command. If you see that usually it says the name node is up. If not, you can do something like this. Okay, so let's look at our latest log. Um, so after formatting, I guess we have to make sure that our name node is up. So now we are going to basically start the name node. So I guess that's the thing why our web UI was not running. So what we do now is again do a Hadoop daemon and we start the name node. So we do a format, and after formatting we start the name node. So now it has the log here. So we look at this log. So we'll see that actually we should look at the out. Basically doesn't have a lot of information. We have to look at the log. So there we'll see that now it has basically started. So now if I go back here, okay, okay, there it is. Okay, so this is how a name node web UI looks like. So let me try to maximize this because this is my VM. So let me see if I'm able to open this right here. I might be able to by just http://nn1 dot cluster 1.com:500. No, it won't work here. So I have to do this from the virtual machine. So basically this is how a name node web UI looks like. So which basically tells you that what is the name node name, what is the port it is running on, and you can browse the file system. So once we add our nodes, we can browse the file system. It tells you what are the current number of blocks in the system, what is the heap size. So since we gave 512 MB, so we can see that it has like 500 MB as the memory right now. So if in production cluster, this will be increased. So uh, so now we'll can see that right now DFS there is no DFS because we don't have any data node. So next what we'll do is we'll add a data node. So so we know this saying that host resolution is not happening. Yeah, that's I think correct. So that's why I went directly in virtual machine so that we can see it. So in your once you have your host resolution and your DNS and everything set up, then something like this would just directly work. And I think I'm also giving ASP. What if I say GSP? Yeah, I mean, since it's not resoluting, so it won't work. So this is how on your real machine it will look like. And right now we don't have any nodes. So live nodes is 0, dead nodes is also 0. There's no nodes in the system. So we know this saying start all.sh. Yeah, start all.sh you can also use. That is used once to start like everything. So right now we just have name node. So we just started the name node. So So how, another question by Vikrant is how 50070 port is associated with 8020 internally? That's a good question. So 8020 port is basically for the for just the TCP port where the name node is running, and 50070 is the port for web UI. So web UI, if you can see that the port here is 50070. So that's the port where web UI is running. And 8020 is the port where your actual process is running. So if we go here and we do something like netstat to basically look at the ports. So, and if I do 8020, you will see that this Java process is listening on this port. And if you do ps minus aux and grep for this process 4123, that's the name node process. So, so on this machine, the TCP port is 8020, where name node is basically running and listening. And for web UI, the port is 50070. So say this is true for the masters in Hadoop. So for job tracker also, we'll have one TCP port where actual job tracker process would be running on the machine. And then for web UI, will we have a different 500 port as we install job tracker, we'll find out. So this is how we basically bring up a name node. So now we have a cluster where name node is formatted and name node is up. And now we have to add data nodes. So what we'll do is now we'll look at some configuration for data nodes. So again, for these two files, core site and HDFS site, these are the files which are basically needed for um, HDFS service. So for name node configuration and data node configuration, we are always going to change these two files. So we'll again go to HDFS site. So we have dfs.name.dir. So when you have a data node, then you have another similar parameter, which is called dfs.data.dir. So I'll just copy this. Actually, I can just write it here. So what I can do is just copy these lines and add another property which will define where my data directories are. So I'll name is at dfs.data.dir, and I will say data.dn, which is where my data nodes data would be stored. And again, in production system, you'll have something like based on the volumes that you have basically mounted, you'll have dn1, then which will point to first volume, comma, data slash dn2, which will mount to second volume, data dash dn3, mount to third volume. So based on that, basically you'll have multiple volumes, multiple disk drives for the data node where will write. So which is same thing that we saw yesterday, that data node would have say 6 times 2 terabyte drive. So that means there are 6 drives, and those 6 drives are where the data is getting written. So in this case, if I say 3, there are 3 drives where the data would be written in round robin fashion. So for this test, basically, again, I will make it just 1. So I made this directory, and again, we have to make sure this directory exists. And before that, I also wanted to see one thing. So yeah, so JPS process is something, JPS command is something that I wanted to tell you. So this is a Java process status. So it tells you what all Java processes are running. So you can see that now that we started name node, so it comes up in the list of processes. So anytime you want to see whether the nodes are up or not, whether name node is up or not, you do a JPS installation and you say the name. You can basically run the JPS command, and you can see in the output what all Java processes are running on the system. And since all Hadoop daemons are Java processes, so you will see the listing here. So right now we have name node. So now what we are going to do is we're going to try starting a data node. So since we have to create the directory, so what I'll do is again sudo mkdir data dn, and I'll again give the ownership to Hadoop because we are going to run it as Hadoop user. So the user that you run as, he should basically be the owner of that directories where data is going to be written. So let's go back to C dash. Hadoop. So we'll go to the bin directory again. And now we are going to basically use the same script, and we are going to say start is the action that we want on the script. And now we are going to say data node. So basically what we are saying is now name node is up, and now we basically can see the data nodes. We can basically name node is ready to accept the data nodes that who want to register themselves. So we are now basically starting a data node here. So we'll run this. So the log goes there. And this deprecated warning that you are seeing is because now with the new release, we have new parameters. So that's also something that we'll see that. So they are saying that this parameter is deprecated, but is still supported. So that's why it is a warning. If this was not supported, then it would just be an error. So now let's look at the data node log. So again, it is in this directory. So what I can do is open this log. So here we can see that it is saying it is starting a data node, and it says the data node metrics are collected, and it is formatting the storage directory. So because it is the first time it has come up, so it saw that data directory is there, but it's not formatted. So like name node, it is again doing the same thing, that it is trying to format the data directory. So So it is formatting it, and then it started the data node at 50010 port. And so again, that's like a web UI port, and there's a Jetty port, and then it assigned this new storage ID. And now basically the data node has started. So it is now, so as we talked about, like whenever data node comes up, it sends a block report. So this is what the block report here that data node is sending is saying, that block report of 0 blocks it generated, and then 3 seconds for RPC and name node processing. So this is basically telling that whenever a data node comes up, the first thing it does is it runs a block report. It does an inventory of what all blocks are there on the data node, and then it creates a block report, and then it sends it to name node, so that name node can update its metadata. So now if we go back and look at and refresh this, so right now we see live nodes are 0, dead nodes are 0. So what we are going to do is we are going to refresh this. So now we have one data node. So if you see, the DFS remaining has changed, live node is 1, and non-DFS remaining has changed. The configure capacity has become to 5.75 GB, which is the size of the data directory. And if you click on live nodes, it should basically show that which is the node. So since we named it NN1, so it is coming as NN1, but once you have your system configured, it will tell you that what is the configured capacity. So for /data/NN, if we look at here, /data/NN, capacity is about 600 MB blocks, sorry, 6 GB. So it is like about 5.78 GB. So that's basically how data nodes get added. And once we have data, then we can see that we go back here, we'll see some blocks here. So instead of 0 blocks, we'll see some blocks. So what we can do is we can now try copying some data. So for example, we have this file. So what we can do is I can do Hadoop fs dash copy from local. And before that, we should look at Hadoop file system listing. So these are, so when I say Hadoop fs-ls, that basically is like we are running a Hadoop system, and then we are running a file system command, which is fs, and then the actual command with a dash at the beginning. So we are saying Hadoop fs-ls, and I do root. It will say that, okay, it's a command, so I have to do like this. So right now there's nothing. So what we can do is we can create something on HDFS. So what we'll do, Hadoop fs-m, we can create a directory called /user. So mostly you will see that every, so like we have home on Unix. So on Hadoop, when people write the data, they always make it slash user. So it will be, you create this directory. And now if you do ls, you will see that there is one directory on Hadoop file system, which is owned by Hadoop, and that directory is user. So now we can create home directory for, say, user Hadoop. So once you do that, if you do ls will still show the same thing. So if you want to see what's within this directory, you have to do something like lsr, which means Hadoop ls recursive. So that will do, that will show you all the directories within this. So lsr will basically show all the subdirectories as well as all the files. So now what we can do is try writing a file, Hadoop fs dash copy from local, or dash put, whatever command we want to use, both will do the same thing. So what we are going to do is copy a file. So when I say copy from local, means I'm trying to copy a file from local system, and I'm trying to upload it to HDFS file system. And HDFS file system is like, this is a directory on HDFS file system where I want to copy a file. So what I'll do is, well, for example, this Hadoop file, which is a binary, I'm just going to copy it under this user. So I'll say something like this. So now the file has copied. So now if I do again lsr, I will see a file here. And since it says a blank, that means it's a file. If it would say D, that means it's a directory. So that's a file system. So now if we go back to here, so now if we refresh it, we have a block here. So that's how basically now what we just did was that from our client, we basically uploaded some data to HDFS. So NameNode got this data file called Hadoop, and it basically saw that this is going to take one block, and it saw one data node. So it uploaded that file on that data node, and hence we have now one block. And as you can see that files as well as directories, they are also basically included in the objects that are there, because they also occupy space. So every file, every directory and block basically is an object for name node, and it occupies memory, so like about 150 bytes. So right now heap size is 226 MB. So it is basically 150 into 5 plus some memory that name node needs to for its own processing. So this is how basically now we basically have a cluster where we have one data node, and we just have uploaded a file. So we have some data, so there's one block here. So we can upload more data, and so we'll keep on having more blocks here. So, and then we didn't configure the block size. So right now by default, the block size is 64 MB, and this block was just 14 kilobytes. So basically this all went under one block, and that's why we have one block on HDFS. So now again, if we run this JPS command, we can see that now we have a name node, and then we have a data node. So next what we can do is we can also have a job tracker. So again, we'll go in the conf directory, and we'll look at this file now. So this is a file. So when we talk about name node and data nodes, we only look at core site and HDFS site. But whenever we talk about job tracker and we talk about task trackers, we always look at MapRed site. So when I open this file, again, this would be blank. So I have to again add a property file here, basically a property tag. So what I can do is I'm gonna go here, and I'm going to define my job tracker here. So just like the file system, I can just say the name of the job tracker. So like we'll say, oops, nn1 dot cluster1.com, and I have to give a port, which I'll say 8021. So this is the port that we have defined for job tracker. So this is like the most basic property that you need for a job tracker. So I'll save this, and Again, go to binary directory, and now I will do Hadoop daemon.sh start, and this time I will say job tracker. And if we have any issue, then job tracker won't be up. So when I run JPS, I see that job tracker is up. So that means now we also have a job tracker in our system. So if I go back here, now what I can do is I can try changing this to 50030, and this is basically your job tracker. So this is how a job tracker looks like. It will say Hadoop MapReduce administration, and it will again tell the cluster summary, which will say the heap size for job tracker. So since we are using Hadoop environment.sh with 512 MB size, so every daemon that we are starting on this node is getting 512 MB of memory, which was same was for name node and same is for job tracker. So we have 512 MB of memory. And if we look here, nodes is 0, because we haven't added a task tracker. So then similarly, we can add a task tracker. Then we have a node here for task tracker. So basically, this is how basically are the configuration files. So this basically is just an idea to show what are the main configuration files and what are the main processes that run in a Hadoop system, how you basically configure them. So this is a very basic installation where we just brought the nodes up and we tried to load some data to HDFS. We're able to see the data. We brought the job tracker up. So in future sessions, basically, we'll try to say run some kind of a job. Uh, so that's the going to the next step. So this is, I guess, a lot. So let's go back and see people have questions. So if we look back at these files, so these are the files we just looked at. So we looked at Hadoop env.sh, where we basically modified our Java home, we specified our Hadoop home, and we looked at our heap size, and then the core site where we basically did the settings for the default file system name. And in HDFS site, we gave the location where name node and data node are basically writing the data. So let's briefly look at the directory where we have the data node. So we have data dn. If you see here, so these are the kind of directories that have created. It's created a blocks being written. So this is where the blocks go. And then we have the current directory, storage directories. So if you go to current directory, we have the blocks here. And then again, we have a version file. So here again, we have the namespace ID. So this is the same namespace ID that we saw in the name node version file. So basically the cluster basically is going to have the same namespace ID. So this is what, when we say that the whole name node as well as data node, they combinedly form a namespace, because that's what is basically being realized here, that we have a namespace ID which is shared by name node as well as data node, and they form basically the namespace for this cluster. And so we look at the JPS. So this is where actual blocks are stored, and then we have TMP directory, blocks being written, which are being written at that time. So I would encourage all of you to try this and play around with this. So Vikrant has a question that, can we change web UI ports, for example, name node from 805070 to some other port? Yes. So these are again the configuration that we are going to look in our next module. So there's a property called dfs.http.address. So that's the property that you change, and you can give a different port number. So by default, basically, you will see that mostly people use these ports. That name node TCP port is mostly 8020, job tracker port is 8021, and web UI for name node is mostly 50070, and for job tracker is always 50030. I mean, when I say always, means that usually people don't change it. They leave these values in production because these are like standard. So you can even go to Cloudera website and you can see Cloudera's ports reference guide. So there also you will see these are like the standard ports. So you guys should definitely go and look at the ports. And so once you install the data node, if you look at the log, there also we saw that 50010 was a port, 50075 was a port that data node uses. So those are two ports that data node uses. So we'll again cover all these things in detail in our future modules. So another question by Vikrant is how 50070 port is associated with 8020 internally. So they are associated in terms of that 8020 is the TCP port where name node does all the RPC, and 50070 is a web UI port. So basically it runs a web server on this port. So all the web UI related stuff where you want to see the status of name node, basically people go to this web UI. So all the web UI requests are directed to 50070 port. That's a web server that's run under name node, and 8020 is the TCP port. So Vikrant is the question, can we change the web UI ports? Yes. So we just discussed that. Okay. So let's go back to our presentation. And so we saw the files that we have changed. There's a MapRed site, and then there's a masters as well as a slaves. So basically, so that's another file that we have to alter. Um, so go to home, cd Hadoop, under conf, we have master file and we have a slaves file. So under master files, we basically provide secondary name node. So once you configure secondary name node, we can add the host name for secondary name node. And under slaves, basically we add all the data nodes. Because the reason for adding here is that if we go under the bin script, there is something called start all, because this is just one data node that we added. So in production, you'll have like thousands of nodes. And if you have to say start or stop data nodes, so you cannot go to individual data node and start on or stop it. So you basically use the script called start all. This will basically just look at the slave script and just do a start all. So these are the files in 1.x. And let's go to our next slide. Yes, I think this session was our first Hadoop installation, so we definitely had to do it carefully, and that's why it took a lot of time. So you can see that they are again showing the 2.x configuration files, the same files that we just looked at. So we have HDFS site, we have core site, Hadoop env.sh, and then we have slaves, we have masters, and additional one is yarn. So once we in our next sessions we'll configure yarn, then we'll look at yarn site.xml. And then these are the ports that we looked at. So dfs.data.dir is the basically property that we basically modified for data node. So these are the list of some deprecated properties in. So now we are doing like a comparison of 1.0 with 2.0. So in 2.0, dfs.data.dir has been changed to dfs.datanode.data.dir. Similarly, dfs.http.ss. So that was a question by Vikrant, that can you change the port for from 50070 to something say 800. So this is the property that you would change. And in 2.0, this property is called dfs.namenode.http-address. And similarly for name node, we said fs.default.name. Now it's called fs.default.fs. So these are the property change. So again, they are not deprecated yet, so you can still use them. But if you are setting up a new cluster, it's always good to basically use these properties for Hadoop 2.0. So usually used we use Hadoop 1.0 release today. So if we do a Hadoop 2.0 release, then old property names are deprecated, but they still work, so they won't fail. So if you go to this link, this will basically give you a list of all these kind of properties that have been deprecated. So I'll again encourage you guys to take a look at it. So again, with CDH4 and even with 5, they are actually with CDH5, they might not work because it's yarn based architecture, but with CDH4, these all used to work. So when you migrate from CDH4 cluster to CDH5, you will have to use all the new property names. So Rudra has a question that does this property dfs.datanode.data.dir mark it as a data node? So basically, when you configure a data node, then you are going to configure this property on the data node. So you are basically going to specify the list of the drives where a data node can write the blocks. So this is the property. So I can say that this property will only be there on a data node. It won't be there on name node. It won't be there on job tracker. This property would only exist on a data node. So hope that answers your question. So runtime environment that we just saw, uh, that we have Hadoop env.sh that we need to modify. In case of yarn, we're going to have yarn.env, yarn-env.sh that we are going to modify. And then we are going to set the Java home parameter that we did. And in addition, we also looked at the heap size. And we also specified our Hadoop home so that all the daemons that come up, they know where Hadoop is installed and from where they need to run. So, and then these uh, property Hadoop env.sh, whenever we run start and stop script as we did in our installation and in our hands-on session today. So that's when this Hadoop env is consulted, and this is the reason you can see that the memory that we see is like 500. For example, this is 512 MB for name nodes because it picked up from hadoop-env.sh. So when you run a production cluster, you have to be very careful that what values you specify for heap size, because if it's a big cluster, you have to make sure you specify a big value like 20 GB instead of 512 MB. In our cluster, we have just one data node, so we made it 512 MB, but in production, it will never run with 512 MB. So question with Rudra is, if I configure this on name node, does the same node act as both name node and data node? Yes, like we did today, right? So we configured our data node and job tracker on the same machine. So right now this node has name node, this node has data node, as you can see by the JPS output. So we have a job tracker here, we have a name node here, we have a data node. So this is like a pseudo distributed cluster now where everything is running on one machine and it's not actually distributed. So that's why we changed this file. So we have the values both for name dir as well as data dir. If it was a data node, then would not have name dir. And if it was a name node, then we won't have data dir. Because this file HDFS site is used by both name node as well as data node, so we have both these parameters here. But in a production setup, when you have just name node, then you don't need to define data node dfs.data.dir, because name node does not need it. Name node is not writing any data, it just needs the place where it needs to update this metadata. Similarly, for data node, you don't need name.dir because data node is not going to update metadata under /data.nn. It's only going to write the data under /data/nn and other directories that you specify here. So that's the another difference that you will see in a real production cluster. So a question by Vikrant is, how data node knows which name node it needs to contact for metadata or vice versa. So yes, so if you see that we specified this file, right, in the core site, we specified that the file system is nn1.cluster.com and 8020. So this is the file from where data node knows that this is the name node running at the port 8020. So that's where I need to contact. So if you change this to a different name node, then data node will start talking to that name node. So this is where basically you will define a data node. So Vikrant, are you able to hear? So another Vikrant's question is, so this file exists on data node as well? Yes. So basically HDFS site and core site will exist on name node as well as data node as well as job tracker also. So, but then the purpose would be different, that in case of name node, HDFS site won't have data dir, but in case of data node, HDFS site will have data dir. So basically configuration parameters will differ, but the files, all of these files will exist on all the nodes. So we might configure certain, but the files will exist everywhere. So Rudra has, how will name node know about all the data nodes? So that's something that we saw, right? That the name node, when we added the name node configuration in this data node. So when data node came up, it sent a block report to this name node. So that's how name node got an information that a data node has come up and it has these many blocks. And that's when the data node was added and we could actually see one live node here. So as and when you keep on adding the data nodes, so this live node count will keep on increasing, and the number of blocks that each data node brings in, it will also keep on increasing here. Yes, so it is through block report. And data node is going to basically RPC that block report to name node every time it comes up. Okay, so let's go back to our presentation. So we are a bit uh, lagging here on this. So again, the same thing that we saw, that core site will have the core input output parameters. HDFS related parameters, which includes name node as well as data node, will always go under HDFS site. And map reduce related parameters, which means all the job tracker as well as task tracker configuration, will always go under maplet site XML. So which is what we did today. And for so that was to 1.x. When 2.x comes, then we will have yarn and we'll have map reduce. So so in that case, core still stays the same, HDFS will still stay the same because HDFS layer does not change in 2.0. And for yarn, again, we'll have yarn site XML where we'll define where the resource manager runs, and for map reduce we'll have the configuration for node managers. So again, this 2.0 more configuration we'll see in our future modules. So for example, this is an example of HDFS site where we are setting the replication factor. So remember yesterday we talked about replication, that every block is replicated by default by 3. But if you add this property, then it changes to 1. So this basically, these are the configuration. So as you can see that every property in Hadoop is defined as a property name value pair. So you'll have the name of the properties, have the value. So for every property, you'll have this kind of a section in the configuration file. And core site, we have the name of the name node, as this is a new API. So it will change to fs.default fs instead of fs.default.name that we just installed. So you guys can also look at this files just to look at the core default. So basically there is core default and there is core site. There is HDFS default and HDFS site. So whatever is there in core default, if you redefine it in core site, then core site basically precedes it. So it basically overrides the parameters defined in core site. Similarly for HDFS site and HDFS default. So if you define something in HDFS site and it's also in HDFS default, so it will always be read from HDFS site. And then for MapRed, again, we have the same thing that um, we have the map reduce job tracker history. So these are again, all these are like configuration properties now, which we are going to discuss in detail in our further session. So now that we know that we have 3 main XMLs that we need to configure, so once we have a bit better understanding of this configuration files, in next sessions we are basically going to configure these and see how we can basically have different properties and based on a system hardware that we have. And in yarn side, basically you will define the resource manager address, which would be the host where it's running, and 8021. So in 1.x it used to be job tracker, but in 2.x it would be yarn resource manager, and it's using the same port that we use for job tracker. So Suman is saying, should we install 1.x or Hadoop 2.x for practice? So I would suggest that since we tried 1.x, so you try 1.x today. And I think in learning management system, there is 2.x also. It's up to you because 2.x has additional yarn side, which we haven't really discussed right as of now. So I would suggest 1.x, but if you are really comfortable with 1.x and you think that you can like understood what we discussed today and it's not really difficult, so you can try 2.x also. But we are going to cover 2.x also in our future modules. So we also looked at the slave files, which will, as we said, that will have all the host. There'll be one line for every data node in case of 1.x, and in case of 2.x, it would be node manager. And then the cluster modes. So these are the three cluster modes. So I think somebody asked this question yesterday also. So now that we have this slide, we can look at it again. So standalone modes, pseudo distributed mode, and fully distributed mode. So standalone mode basically means is there nothing is running. So you everything just there's just one JVM, and you just install Hadoop. It has no data nodes, it has no MapReduce. So you just use it in the local mode to do some testing. So this is not really useful in terms of like understanding or doing so. It's mostly for testing and development purposes. So mostly people, when they learn, they go with the pseudo distributed mode, which is what we did today, that on one machine we run mostly all the daemons. And then there's fully distributed mode, which is installed in production, where every you'll have a cluster of machines, and every node and every host basically would be a separate machine. And then there are some examples of 1.x clusters and the configuration that people are running. So Facebook, as everybody is interested in knowing about Facebook, so we have some data about Facebook, that they use Hadoop to store copies of their log data, dimensional data, and their reporting and analytics. And then they have 1100 machine cluster with 8800 cores and about 12 petabytes of storage. So that's a big cluster. So in this case, definitely Node and Job Tracker would be on separate machines, and they will be high-end machines with a lot of RAM. And they have another 300 node cluster with 2400 cores and about 3 petabyte of storage. So each node has 8 cores. As you can see, the 1100 machine into 8 becomes 8800 cores. So there are 8 cores, and these cores will run both mappers as well as reducers. So in our future um, session, we'll see how we basically define how many mappers or reducers based on number of cores. And then there's 12 terabyte storage per node, and it would be basically something like, say, 6 drives of 2 terabytes each. And they use streaming. So we'll see there's something called Hadoop streaming, and they use Java APIs. So those are things that they use. So just a brief overview of what we did today. So we did started a name node, which was again this web UI that we showed. So HTTP localhost at 50070 port. And then we have job tracker, which has 50030 port, which is something that we brought up. And then these are basically managing these slave hosts, which are defined under slave files, which act as both data node as well as task tracker. And this is the same architecture that we discussed yesterday. So in Relais, now you can actually relate this to what we did practically today, that from client. So when I ran up the command to copy the data, so then that was like a client where I basically contacted name node, and then name node saw a data node where it wrote that data, and then we had some blocks in the cluster. So we started the job tracker, and in our next sessions, we'll basically run some jobs, and then we'll see that how task trackers work and how we debug it. So, so Suman had a question with us, and Raghunath has a question that for high availability in big organization, will they install NameNode on mainframes like system? No, mostly big organizations which are enterprise level, they will always go with something like Red Hat or CentOS, or they might go with Ubuntu. But mostly enterprise level organizations which don't have like a lot of developers, they will definitely go with a support contract with something like somebody like Red Hat, because that's a preferred and system OS for all the major big installations. So, and then for as we talked about name node, that they will definitely have big RAM size for name nodes. If it's a big cluster, they'll have something like 70 to like 96 gig RAM for name node, and same for job tracker also. So looks like this we discussed in our revision slide also. And then a cluster configuration. So this is something that I guess somebody asked yesterday also, that if you have you can have multiple name nodes. So everything, all the nodes are in racks. So here we have 3 racks, and each rack has like say a few nodes. So in this picture we see 4 nodes per rack, but definitely you will have more than that. So most racks so you can see that racks have like, it depends on the kind of rack, but it ranges from like 12 to 26 in a normal rack. You can even have get a high end rack where you have more than 26 nodes, but usually it is like 12 to between 12 to 26 that I have seen. And then you have switches here, which basically, and then you have your client gateway from where you are basically going to submit the job, and it goes to name node, and the name node will basically contact the slave nodes. And then we talk about replication. So if you have racks, then the blocks will go to like different racks. So name node will try to make sure that there's one copy on each rack, so that in case say this rack goes down, you still have other copies. And this is a cluster configuration. So there's 10 gigabit switch, and you have switches in between, and they are like multi-way. They are uh, replicated twice, and there you have your nodes. And at in one of the racks you have your job tracker. So in you have your nodes, and in another rack you have name node. And you can see that 2 times 10 gigabit um, network. So that's why, because there's a lot of data movement happens in a Hadoop job, because once mappers are done, then reducers, so mappers might run here on the individual nodes. But when reducers have to run, one reducer might run here, one reducer might run in this node, one reducer might run on this node. So in that case, data from this mapper, this mapper, this mapper might need to be moved to this node. So that's when this network is going to help. So that's why these are like well replicated, and they are high-end switches, and 10 gigabit Ethernet. So that, I think this was also another question from somebody yesterday, that can we look at the rack. So I think these slides cover these configurations. So typical use case. So basically, we are looking at the hardware. That name node will have RAM like 64 gigs, and hard disk is not really needed a lot. So we'll have something like 1 terabyte, and processor would have 8 cores, and data node has 16 gigs. So nowadays data nodes don't have 16 gigs. So nowadays I think it has increased a lot. So it would go to something like 96 gigs, because with MR2 you're not going to run just the mappers and reducers, you're going to run other things also. So it needs more memory. And especially when you run tools like Impala, Spark, they are all memory intensive. So nowadays people tend to go with high end data nodes in terms of RAM. And hard disk, there will be like few drives of some terabytes each. So it ranges from 2 to 4. So most people nowadays, if they buy a new hardware, they will go with 4 terabytes. So this slide is needs to be, I guess, a bit updated. So similar, secondary name node is almost same as primary name node, but it doesn't need that much RAM, because it is not doing the heavy lifting of keeping the metadata in memory. It is just getting the data from name node. But in case your name node fails and you have to use the secondary name node as a primary name node, you have to start name node on this. So people try to keep it as same configuration as name node, so that in case this node is getting repaired, this name node can actually be used as the real name node. And so that's for data node. So yeah, these are typical configurations. I think we discussed this earlier also, that name node does not need a lot of cores or a lot of hard disk, but it needs a lot of RAM. And data nodes, they don't need a lot of RAM. They need a lot of RAM also. They need a lot of disk space also, and cores also. So this says 2 cores, but usually um, data nodes are like 10 core. They'll have 10 to 16 kind of cores, because they have to run a lot of mappers and reducers. So, and then what are you going to, basically what kind of cluster are you going to use? If it's a single machine, if it's a small cluster, or it's a large cluster. So single machine you will use only for testing or developing. Like today we basically deployed a single machine. And once you basically want to go in production in Hadoop, you will start with a small cluster of 4 to 6 nodes, and then your volume of data increases, and that's when you decide to set up a new large cluster. So in that case, you will basically need high-end data nodes. You will have racks, and you'll have the switches and routers which are having a good speed, gigabits. So usually people go with 10 gigabit kind of uh, adapters, and then you're going to store more data in there, and you need more memory, so you will go with like bit high end data nodes. So that's how you basically move towards a large cluster. Okay, so there's some assignments. So today we did multi-node. There's a multi-node Hadoop 1.0 using virtual machine in VMware VirtualBox. So we did a virtual box, but we did a single node. So you can try with the multi-node. So there are documents present in the learning management system, and similarly there is a single node Hadoop 2.0 question also. So I think Suman asked that should we go with 1.0 or 2.0. So you can use that document, and you can even start with 2.0 and do a single node. And then you can also try looking at Pig and Hive setup. So just try to basically install it and look at it. You don't have to go in detail. We'll cover that in our future sessions, but just to be um, aware of and know what they are. And so that is the end of today's session. So it might be heavy for a lot of people in terms of installing and looking at the configuration files, bringing the different components up and looking at the web UI. So we can take up some questions, and if you have questions, you can also, yes, as always email hadoop admin@eureka.in. So in case somebody has questions, please go ahead. So Vinod has a question, where can I get this PDF? So again, Vinod, this would be on the learning management system. So let me go back here. So the same thing here. So this yesterday was module 1, today is module 2. So if you once you click on module 2, you'll have the class recording which will be uploaded in next 6 hours, and then you will have this module presentation. So this is a presentation that I'm using right now, so you can just download it or you can watch it. And then there's a quiz, and there's week 2 assignment, and that we just talked about this Pig and Hive setup that you can do on Ubuntu. So we also looked at Ubuntu. So in case you have to refer to this um, present recorded presentation, that would be uploaded, and you can look at the Ubuntu setup. And there is Hadoop 2.0 single node cluster installation, and then is a virtual multi-node cluster that I'll encourage all of you to set this up and email us or call us if you face any issues. Okay, so any more questions? Anyone? I know this session was kind of heavy, so people must be exhausted and need some time to read all this and try this on your own, because we did a lot of things today, so a lot of things to digest. So I think that's why we covered this today, so that you have a time of about 4 or 5 days. So you can actually do this and look at various configuration files. And if you get a time, you should definitely try using the multi-node, where you have like name node on a separate virtual machine, data node on a separate virtual machine, so that you can configure just the data node specific properties on the data node virtual machine, name node specific on name node, and job tracker specific on job tracker node. So that way you will know that you don't need all the properties to be in one file. So plus we are going to again discuss all of this in detail. So so Gandhi is saying that thank you very much, and there are a lot of things to work on during this week. Yes. So I guess, yeah, this is like kind of basis for your course, that you once you set up this Hadoop cluster and you know the core components, so rest of the things will start falling in place. That when we start discussing about 2.0, we'll discuss the job scheduler, we'll discuss job tracker, we'll discuss Cloudera manager monitoring. So that all the basis of everything is that you have an up and running cluster, and you can then run jobs on it and look at things and monitor it. So so Suman is saying it was good informative session, so I'm glad, Suman, that it was informative and everybody got to learn a little bit more today. Okay, so in case nobody has any more questions, I guess we can call it a day. And again, I would encourage all of you to go to LMS and take the quiz, do the assignments, so that next week you come with more questions and we have a more interactive session. So thanks everyone and have a good day. So there's one question by Suman that if I install using Red Hat, I will get support from Edureka, right? Yeah. So if you are stuck somewhere, yeah, definitely. Thanks, Nanda Kumar is saying thanks. And Raghunath is saying it was good session, informative. Thanks, Raghu. I'm glad that we got some more information and now you have a lot of things to work on this week. Thanks, Ravindra says it was a good session. So you're welcome, Ravindra. Okay, so I guess then uh, I'll end this session here. And if you still have any questions or any doubts, you should definitely email us and we'll definitely help you with any doubts that you have. So thanks, everyone.